welcome to USC. My name is Burçin Becerik Görver. I am the department chair here in the Department of Civil and Environmental Engineering. And it's my pleasure to have all of you here, and it's my pleasure to also host this event here at USC. So I'll start with a very brief introduction, and then we'll start with our program. As you know, today we will be talking about introducing and embedding safety culture concepts in undergraduate studies. It does say undergraduate, but I would love also to include graduate studies because we have a very strong graduate program here at USC. Actually, two of them focusing on construction, one construction management and another one on construction engineering. So the purpose of this symposia, and this is one of the many that, as you know, and it's this time we're hosting it here at USC next week in Oregon, and I think the previous one was also in Washington, D.C., is to convene and promote dialogue between academia and industry to help better prepare students in higher education to understand safety culture as part of their future careers. As you can appreciate, this is a very important mission. Okay, so I kind of covered this one. Last one was in Virginia, I believe. And this one, you're here. Next one is going to be Oregon State. In May, we will be meeting in Purdue, and September, North Carolina State University. So this is our agenda. You will find the agenda on the table as well. And there are a few other handouts that you will find, including breakout sessions and your tables for the afternoon. So we will have 3 keynotes and 2 panels. One keynote will focus on industry, another on academia, and the third one, maybe differently than the previous symposia, on technology. Because we do believe that technology might improve or hinder construction safety depending on the application. So we would like to have that conversation. And here at USC, our construction faculty are very strong on technology. So we wanted to bring that as an additional theme to discuss here today. And then we will have also 2 panels, one focusing on industry practices and another one on higher education concepts. I would like to thank our, of course, National Academies of Sciences, Engineering and Medicine, National Academy of Construction, who approached us to host this event, but also very much to our CMAA group. I'm the department chair, but I should not take the credit as our CMAA group, and Hank Hoffman is the advisor for our CMAA chapter here, who will say a few words.
It's our pleasure to host this great event. We are planning a very interesting program I think you'll all be interested in. And I'll thank you for braving the weather elements to come early this morning. It's very nice here. Like Dr. Bershwick said, I'm the director of the Construction Engineering Management Program here. And again, a warm welcome to everyone here. I think you'll really enjoy the program. And again, like Dr. Bershwick said, we couldn't do it without our students. They were the driving force behind this whole event. Anyway, it's really our pleasure to host this, and maybe hopefully we can host some more future events like this, because we consider safety a very, very important topic, especially in construction, which is such a risky business with a high accident rate. And hopefully we can do something to bring that down. So without further ado, I'd like to introduce our next speaker, very distinguished gentleman with a long career in our construction industry. Ed Gibson is the president, CEO of the National Academy of Construction, having held that position since January 2023. He's also professor emeritus at the Construction Management and Engineering in the Delhi Webb School of Construction at Arizona State University, having retired from academia in 2022. He spent 8 years as an Army officer and positions in industry before embarking on a 34-year successful career as a faculty member, holding endowed positions at University of Texas Austin, the University of Alabama, and then Arizona State University. From 2010 to 2018, he served as director of the School of Sustainable Engineering and the Built Environment at Arizona State University, overseeing 6 academic programs and over 1,700 students. He has supervised over 125 master's and doctorate students and has been president of the Architectural Engineering Institute of the American Society of Civil Engineers, ASCE, in 2006-2007, and was elected distinguished member of ASCE in 2020. He also served as a Fulbright Fellow in Norway in 2004. He was a visiting academic fellow at Cambridge University in spring 2019. He was awarded the 2016 ASCE Purifor Award for Outstanding Research and the NAC Richard L. Tucker Service Award in 2020. In 2022, he was honored with the Richard L. Tucker Leadership and Service Award from CII for his work in the Institute from 1988 to 2019. Ed is a licensed engineer in Texas, and I can probably go on all morning talking about his acclimates, but I think I'm running out of time. So it's my pleasure to introduce Dr. Ed Gibson.
And again, thank you very much to USC, CMAA, and we do have a relationship with the National Academies of Engineering. I did want to point out the sponsors for our symposia today, and you can kind of see those companies here who've given funding to help us put these on over this spring, and we're very, very appreciative of them as well. And thank you for your attendance and support today. So a little bit about the National Academy of Construction. It was established in 1999, really as an organization across all sectors of the construction industry, not just engineers, but constructors, lawyers, people in the surety industry, subcontractors, and so on and so forth. And the whole point was to honor those people, because there really wasn't a way to honor those folks nationally in the U.S., but also to take that embodied knowledge and try to improve our industry. We have about 475 members right now. And so first we honor, secondly, we provide our collective knowledge, and I'll talk about that a little bit later. And then the thought process is also to build the next generation of leaders, which is part of why we're doing this. We want to make sure that those leaders who are in our undergraduate education and graduate education come out with a set of skills and knowledge, first to keep them out of trouble, but secondly, to help them come in and help other companies as we move forward. Real quick safety moment. I think if we have some kind of an event, it's pretty easy to find the exits. We would exit the building and rally outside over here on this street or in this patio area. Hopefully we don't have anything like that happens. I did want to talk a little bit about a safety moment, though, that I think is really important, and it kind of sets the theme for what we're talking about today. Many of you may have seen this pyramid. It's called the Heinrich Pyramid, and came from, I think, the 30s, and then it was looked at by a guy named Bird in the 60s at DuPont, and basically analyzing data showed that there are 60 unsafe acts or first aid incidents for every 30 serious incidents, for every fatality in our industry. And what happened is a lot of people focused on those 600, and we've done a good job in reducing minor issues and so on and so forth. But what we found, and I'll show you the data in just a moment, what we found is if you don't step outside the box, if you don't have training, if it's not a fully engaged group of constructors from the field level all the way through senior management, then we don't hit the fatalities. We don't find the catastrophic events as much as we should. And so, the question is, do you and your people have the right safety IQ? Which means that we're thinking both of minor issues. We're not taking anything for granted in terms of unsafe actions and decisions, but we're also looking at high energy issues, potential for catastrophic failure, and so on and so forth. And there's a reason for doing that. And if we look at the U.S., most of you are very familiar with these numbers. If you're not, and it's a surprise to you, then become familiar with these numbers. 8% of the U.S. workforce, about 10 million people in our construction industry, but 22% of the fatalities in the U.S. every year on average. About 1,000 deaths annually for the last 25 years. About 170,000 serious injuries. And basically it's stagnant. And so we need to take steps to do things differently. I think it was Joseph Duran who said, if you keep on doing the same things the same way and expect to change, then you're crazy. So we've got to do some things differently. Just not to bore you too much with statistics, but in 2023, workplace fatalities in the construction industries were at 1,075, which was the highest number of fatalities since 2007. And if we looked at the number of fatalities in construction between 2002 and 2023, if you're into statistical process control, this process is in control. It's just stagnant. It's right there. Our process says we're going to kill 1,000 people a year. And I just don't find that acceptable, because those people have families and kids, and they have a life out in front of them. If you look at the data spread out over that time, 22,603 fatalities, so we're averaging about 1,000 a year. And it goes up and down a little bit, and typically that has to do with how much construction is put in place. But, we need to do something. And one place is trying to get this more into our classroom and prepare our students who are going to be out there and be leaders to be leaders in safety. The good news is we're not the most hazardous industry. We're number 3. And so about 10 fatalities per 100,000 workers. And there's a reason for that. Our industry has a lot of hazards. And we see that play out in the news a lot. And so it's just something to keep in mind. The rate of fatalities, and the one to look at here is the blue line kind of in the middle with the squares. It's absolutely flat, about 10 fatalities per 100,000 workers. And this data is about 15 years worth of data, and it stayed flat as we've moved forward. One thing that's pretty interesting is that if we looked at the number of fatalities by business size, about 87% of the fatalities are in companies that are 99 employees or less. That includes subcontractors, general contractors, and so on. And what I would submit to you is that many of our students go to work for those companies. They go to work for small companies so they can have an inordinate impact if they understand safety culture and safety systems to try to improve those things. But still 13% of fatalities happen with companies that have over 100 employees. So it's still happening even there. And hazardous exposure will not go away. Exposure to hazardous equipment, typically the green is at least once a week, distracting or uncomfortable noise. The green is once a week, and so on. So the industry does have a tendency to put us in harm's way or potential harm's way, and that's not going to change. Perhaps it might get a little better, but we still are going to have those situations. I think another thing that is really interesting, and this is 2022 number, 5,300. So the rate of death by suicide in the construction industry was 53.3 per 100,000 workers in 2022. That's 5 times the rate of death through industrial accident in the construction industry. And so it had the highest suicide rate for both men and women of any industry sector. And interestingly enough, architecture and engineering, design were in the top 12 occupations experience in suicides. You can see some of the other results there. 84% of employees in 2022 reported at least one mental health challenge. And so this is part of what we're talking about with safety culture, safety and health culture and mental health culture. And I know Bill's going to talk a little bit about that later. And certainly there are a lot of factors that play into that as we move forward. And so having our students and undergrads and grad students understand this and have the ability to move forward with it is really important. We'll make sure I get in on time. So the good news, and I think it is really good news, is that both research and industry experience show that injuries and fatalities do not have to occur. Many companies work millions of hours without serious injury, fatality, and sometimes even recordable injuries, fairly minor injuries. And there's a way to do that, and it's combining good safety systems and discipline in the way we approach the jobs with a safety culture that goes from the top of the organization to the very bottom and says that every employee is valued and every employee is involved in making sure that no one else doesn't go home that afternoon. And I think our professional codes of ethics, in fact, I know they do, clearly state as engineers and as constructors, we have an obligation to safety and health of the public, which includes our workforce, both during design and construction. You'll hear a little bit about prevention through design a little bit later today. So the goal today really is to bring the supply side of future leaders, the educational part, with the demand side of future leaders, the industry. And I know we have a lot of industry folks today, so that we can bring out a step change in our industry. Just think if we could reduce the number of fatalities in half. That's still too many, but we have to attack it from many different places. And I think we're going to talk a little bit about technology maybe as a driver as well today. So you may ask, what's safety culture? This is our definition of safety culture at NAC. It's an all-employee system. I think that's the most important phrase, where we share in beliefs and practices to help shape our behavior, the soft side of things, to drive the way in which all work is performed. I know I had a safety director for Mortensen come talk to my class one time, and one of the things when I was at ASU as a faculty member, one of the things that struck me during that presentation, he said, the only way to do something is the safe way. And so everything is planned ahead of time. We don't take chances. We keep our people out of harm's way. And they had at the time done 1.5 million hours in the Phoenix area without a lost workday, without a recordable incident, made completely zero for 1.5 million hours. So we've had some of these safety symposia in the past. I know Elias is here. He attended one in Boulder, and Ken's been to a number of these. You can kind of see when these happened in the past. We learned a lot from these, and we're doing this again, as Urson showed a little bit earlier. And some of the things that we learned from those symposia, how do you embed safety and safety culture into in-class? It doesn't have to be necessarily a separate class devoted to safety, even though it can be, but it's making sure that safety content is in multiple classes. And many times that's not hard to do. When we're teaching students about things, asking them to really think about how you would approach safety here. Develop case studies, which we're working on a little bit now at NAC. Get guest speakers from industry, which hopefully our academic folk here can develop some networks. include safety into projects and assignments as one question or two questions about what we're doing as we're doing the assignments, and then do a job hazard analysis for each laboratory that's conducted, which is kind of a neat way to do it. It becomes part of how we focus on work to happen ahead of time. But safety culture is beyond the classroom. Field trips, safety competitions, OSHA training for all students, whether it's a class or providing opportunities for all of our students to take their OSHA 10 or 30 cards. At ASU, and I know in a lot of other places, we provided PPE for students as they entered the program in a ceremony. We handed them a vest and safety glasses and gloves and stuff like that, and because we knew they were going to be on the job site in their first semester as part of field trips. There are a lot of barriers, and some of those are listed here. I think one of the big barriers is many faculty have no background in safety. They're very good at finite analysis or doing hydrological calculations and those kind of things, but they've never really been exposed to this. Certainly it's hard to make room in existing curriculum. There's a lot of pushback on that. How do you motivate faculty to do that? Well, hopefully the statistics that I've shown help with that, but it's something that we keep in front of us. On your table, there are actually a couple of handouts, and one of those is that at NAC, since our Symposia 2 years ago, we actually wrote a number of executive insights on safety culture, and there's background information. We also have 8 Get the NAC podcasts on safety culture, and so these are available for free, and you can listen in on them. You can download these things and use them. You see the 19 understanding safety culture, audits and surveys, gaining buy-in from employees, and so on. These are all subjects that we're going to probably talk about today, and those are available, and we very much encourage you to go in and look at those and use those perhaps in the classroom or perhaps in your companies. We also publish proceedings from the first set of Symposia. You can see where that is now. Please download that. It has a lot of other ideas that I didn't show, and I think that's kind of where we're coming from there. Oops, I think we might be. There we go. All right, let me go back one. And so that's pretty much, the intro. Sorry, it was kind of stark statistics, but I think it's worthwhile for us to review those, and then it serves as a good path forward. So please use the material that's here. One other thing that's in this handout is on the first page, which is a little encapsulated thing that was written by Jack Tollner, who's a member of NAC. He was the senior safety director for ExxonMobil for a number of years. And it really kind of gives a personal story of why he thinks we should teach undergraduates and graduate students safety culture education. And you can kind of see that reading through it. It's a personal story that he experienced. And I know many of us that started in the industry in the 70s and 80s, it was, okay, go be safe, watch out for yourself, talk to other people. There really wasn't a system in place to help protect us. So that's all I have this morning, and let me introduce our first speaker. First speaker is Bill Calhoun. He's the Executive Vice President and Chairman of Clark Construction. I think he's a member of the National Academy of Construction, and he and I were talking this morning about some of our recollections of our early careers in the industry. He's been very much involved in Clark's growth and also its safety journey. So I think you're going to really enjoy listening to his presentation.
Thank you, Ed. You gave me a promotion. I'm vice chairman of the company, not chairman, but I'll accept the title. It's great to be with you all today. I want to thank Ed, and I want to thank Tony Laquetta, chair of the safety committee, NAC, the whole NAC organization, and the safety group there, because they brought forward these symposium, which are broadening the dialogue on safety. to academia. And I think this is going to undoubtedly yield great results. We impact millions of people on our job sites across the nation every day. And so this is going to affect the outcome of people. We're dealing with real people. I want to thank Burson and Hank and USC certainly for hosting here today. I got out of Georgia Tech in 81. I was an engineering student. And know what I said? I got out. All of us from Georgia Tech, we never talk about when we graduated. We talk about when we got out. I'm not sure what that means, but it's just the way we refer to that. But I went to work for another large national general contractor for a couple of years. And in 83, I came over to the Clark organization, and I worked around the country in successive assignments into what I do today. So my perspective is that of a builder. Clark is a builder. So I want to start, I guess this green button here is okay. Just a moment about Clark and what we do. So again, you have a better understanding of my perspective. We're a large national, privately owned general contractor, been in business a long time. We operate from offices throughout the United States, and then some of these offices are bigger than others. We do about $6 billion worth of work a year. That's going to click up. We've had a great year in 24 and signed new work over $9 billion. So this will click up. It's a sign of the times. I really want you to pay attention to those bottom two numbers. There are 20,000 people, workers, craft labor on our projects every day. And that's an exposure. And anything we do that impacts their lives to the better and sends every single man and woman home every night the way they came to work is really our goal. It is zero. And then we have about 1,700 folks that are craft labor where we self-perform. We're still one of the general contractors in the business and self-performs a significant amount of the work that we do. A quick vision as to some of the kinds of work we do. We work in both building as well as infrastructure. Our $6-7 billion a year given year is 25 to 30% in infrastructure. We have a couple of road building companies. We do tunneling. And then the rest is building throughout the United States. But a couple of projects you might notice to represent the different product types. Top left is Chase Center in San Francisco. That's sports. We do a lot of sports work. That next going clockwise is the Stanford Adult Hospital. We're a very big hospital builder throughout the nation. Bottom right is the most recent addition, about $1 billion addition to the Seattle Convention Center, known as the Annex. And then the project next to that is the ACMA, or Orange County Museum of Art. Between museums and convention centers, we're probably the most experienced in the country among those. We do a lot of that work and have for a long time. And then, not to give short shrift to our civil folks, but that bottom left is I don't know if you can see it, but it's the cutter head of a front face of a tunnel boring machine coming through the rock face for a large water tunnel. So we do also do quite a bit of civil work throughout the country. And then close to home here, I'd be remiss for not pointing out the good fortune we have to be working as a partner currently and have for a long time with USC. Top left is the Rawlinson women's soccer and lacrosse field, which will be ready for fall start of season. If anybody's wondering, yes, it will be. The Bloom Performance Center, I think that field is about ready now for the team to start their practices. Both of those projects we built with the field first so that we could accommodate the needs of the teams and then finishing the structures around them. Bottom right is the Galen Center, a little bit older. Bottom middle, you may not recognize, but that was when we built that was known as the LAC USC Medical Center. I think now maybe the LA General Hospital. And then bottom left, of course, is the baseball stadium. So we've appreciated our partnership, having a privilege to work with USC for a long time and hire their grads. So thank you for the opportunity to be here and be part of this. So Ed asked me if I would think about a couple of things as the goals. I think he might have mentioned them already. Benefits and implications of what does a safety culture mean? I think that's somewhat obvious where we're trying to get to, but what is a safety culture? Maybe a little bit more elusive in terms of what does that really mean? And then what are the expectations? What are our expectations of grads? And so as I thought about those two goals, four or five things instantly came to mind, and I want to put them forward right up front in case I ran out of time here. I want people to be thinking about these, not only today and what I had to say, but really as you go forward in life. I think these are things that are important to think about with regard to safety and construction. And I'm going to start and speak a little bit about the evolution of safety because I think it helps to understand where we've been and where we are as we look for how to improve. And Ed talked about we plateaued and we need to improve. And so a little bit about where we've come from is probably maybe entertaining, but it's also, I think, helpful. One thing that I tell people, and I remind myself, is you're responsible for your safety every single day. And it's not just a question of, did you comply with the rules? Did you follow OSHA? Did you follow your own policies? We talk about rules and tools, but you could be in a situation tomorrow at home. And you need to evaluate, eyes wide open, be aware, be present. Of course, we want to advance our training and knowledge always. That's our responsibility. Part of that is today, but it doesn't stop. Ask questions and challenge the status quo. I'm going to tell a quick story about that. And I think that is a very healthy way to look at life, because we're going to get to improvements by challenging things that we've always done. And then I think last is accept this notion of safety culture of care. How do we get into the minds and into the hearts, and how do we get beyond the rules and tools? What does that mean? And how do you position yourself inside that and help as we progress? So this picture is amusing. You've all seen it probably hundreds of times, and although it captures a time in Americana, it's entertaining, but it really represents all that's wrong with the thinking about construction. I mean, this is construction's about fearless risk takers, a bunch of old guys sitting on a beam and not having a fear in the world. Nothing could represent the mindset and safety in a construction today worse than that picture. I put together this notional, anecdotal, somewhat time-related talk about safety, and it's not carefully researched peer review, but it kind of takes you from where we were to where we are now. And when I started in 81, the industry talked about construction as being inherently unsafe, and accidents happen. And we all looked at if we even looked at, as a young person coming in, I'm not sure when I even got exposed to safety statistics, but we looked at recordable incident rate, lost time incident rate, EMR. EMR needed to be below 1, which is the modification rate that the insurance industries look at. And if you were doing better than the industry averages, well, you were doing okay. And so that's where we started, and safety became a priority. We started to do, I think the Corps of Engineers may have put us into this job hazard analysis, which was new, and you'd sit down and evaluate the risk of an operation on a project, and it was forward-looking for that entire operation. You did it one time. With the advent of CSIP and OSIP, contractor-controlled insurance programs, we began to have some financial incentive in performance of our job, so we started to focus more. Maybe we needed to focus more on safety because we could make money. OSHA 10 hours and then OSHA 30 hours, both of them are more like a window. You get trained, you look at some pictures, your eye is tuned into what to look for, but it's a snapshot. It's not an ongoing. And we've evolved. We've evolved into safe plans of action. Some of us do them as we do safe plan of action every day for every element of the work, every crew, or some just before the start of each new element of the work. But we talked about near misses, and are we evaluating near misses? How are we getting to forward-looking indicators? Very much where our thinking is today. And we're talking about a culture. And I think there's great new technology development that we're going to speak some about a little bit later today. But I want to talk about relationships. I think as we get beyond the rules and tools, what do relationships mean in the establishment of this culture of care? And Ed mentioned mental health and suicide, and I am going to touch on that because I think we're going to need to get out of our comfort zone of rules and tools. And how do we get into that area of life which we're not necessarily trained on, which is the human interaction and relationships? And of course, we're at a point today where 0 is the goal, and there should be no ambiguity about that. It's not about averages; it's about 0, and that's where we want to get to. I think before I get into this, I do want to say something else. And when I look at those pictures I showed a minute ago, I feel, we've accomplished great things, built great facilities. I think about people. I think about the people in our organization that have grown in responsibility along the way, the great problems we've solved, the partnerships with our subcontractors, the partnerships with our owners. But I also think about people that were hurt along the way. And I think about, one comes to mind, Jose, our whole last name. Jose in 2012 fell 4 feet or maybe a little under 4 feet. And when he fell, he was disassembling scaffolding on one of our jobs. Longtime Clark employee. He fell. He hit his head. His hard hat came up before he hit the ground. Traumatic brain injury. Never could return to work. And so as I look at the great accomplishments of our industry and of our organization, I think about people that I know along the way. And it brings it right forward about the importance of what we're doing here today and every day as we think about construction and safety. So Ed put some stats up there. It's a little bit shorter time frame, says the same thing. One might argue, well, on the recordable incident rate, which is a backwards looking rate, where the industry is improving. It's not where it needs to be, certainly. We may have gotten better by about a third over the last, whatever that is, 14, 15 years. And you might feel like we're moving the needle, which we are, not far enough. But then you look at the other stat that he showed and get a shorter time frame. But fatalities have grown by about a third in that same time frame. So this should be alarming. This should be a wake-up call. What's going on? We need to do better than we're doing. And this statistic sticks with me. So one of the points I made is challenge the status quo. And I'm going to tell a quick story, and I will say that the Clark journey from hard hats to helmets has been one that's near and dear to me and to our company. And it's an example. I don't want to make this all about Clark. I want to make about an example of we did things in this industry for a long time. We wore hard hats. Some still do. And nobody challenged that status quo. But we did. And it came from a couple people high up in Clark when in 2012, I mentioned Jose had an injury. And a long-time Clark employee, we immediately, these two people got together and said, why did that happen? Did a root cause analysis and were alarmed with the stats that they saw, that many traumatic brain injuries in our industry occur when a hard hat falls off from a fall of less than 6 feet. So there was no requirement to tie off. And why did that happen? And that led to an immediate working with CASC as a manufacturer, manufactures helmets for, I think it was the climbing industry, maybe other. And we learned that the ANSI standard that OSHA requires us to comply with regard to the head protection was mainly for downward force of a falling object. It really didn't deal with side impact, the torsional impact. It certainly didn't deal with staying on the head in a fall. And so we began developing a hard hat with CASC shortly after this incident, 2012. You could see we had a second employee, long-term Clark employee, Nelson, who injured himself. He was unloading a flatbed truck. So he fell off a flatbed truck. Seemingly simple operation. Again, hard hat fell off before he hit his head, traumatic brain injury. So we accelerated the development of the helmet, put it out to our self-performing concrete crews, got the feedback, made some adjustments, got third-party testing, added accessories, the flip-down sun shield and safety glasses. I think we now have a sunshade in the back. And we put it out to all Clark employees, and we made it mandatory. And we began to try to coerce, or probably not the right word, but convince our subcontractors that they need to do this as well. And there was a lot of pushback. They were not well accepted. It's changed. A lot of people don't like change in our industry. And we finally decided, after spending a significant amount of money and trying to control the industry to move our direction, we made it mandatory on Clark jobs. If you're going to be a subcontractor on Clark job, it's written to the subcontractor, you're going to wear a helmet on our projects. Happy to say the industry is largely moving this direction now. We see a lot of it, but it's not all there. And I don't know why, but I like to get the word out. And I often get, I mention this in talks on occasion, and later I'll get a call from a CEO of a company and say, we listened to you, we didn't believe you, we did our research, and now we're there. So please get your company there if you're not already. I don't have time to play this video, but 2018, Marvin Taylor, concrete labor, working on a slab, didn't fall from height, was cleaning before a wall, a short stub wall for a wall pour. Got his foot somehow wedged, lost his balance, fell over backwards, and hit his head. And you could tell from the picture the crack in the hat would have been a traumatic brain injury. He got up, took his helmet off, and he walked away. And for a long time, I kept that picture on my bulletin board at work because it reminds me every day that we can change the industry and we can impact people's lives. And it's a very clear reminder to me that what we do is really important. So another thing in challenging the status quo, and I think most of the community, the construction community is there today, that we look at these OSHA required rates and we realize there's a lot in those rates which are buried data and they're backward looking and it's hard to use that for predictable actions. Any of you might see a bee sting there, as any good Georgia Tech grad would tell you. That's a yellow jacket. And a yellow jacket that results in a yellow jacket sting that results in a swollen finger or reaction. You might be required to take Benadryl. That's a recordable incident. So is a fatal injury, a recordable incident, and a whole lot in between. And when all those things get put in a bucket for compliance with OSHA, we miss critical data that we can use. And I think most everyone is there. I want to give a shout out to University of Colorado, or Dr. Hallowell, Construction Safety Research Alliance, which we're a member of. Some great research done to formulate that. What you see, there's an energy wheel, which really, with a lot of really good input and research, shows the origin of where's the energy come from that results over time or manifests it in injuries in our workplace. Clark, like many other general contractors, have taken this research and said, how can we make it work for our company and relatable to the trades in the field as we talk about safety? And so we have, I think it might be Sunt who has their rendition of this is, I think it's the sticky, which is stuff that could kill you. We call it the critical 8. And we're going to talk a little bit more about the critical 8 because it's really about how we are thinking about safety today and as we look forward. But along with the critical 8, near miss reporting, we're trying to get to severity ratings on incidents and near misses as well as recordable events. And we bring all that data together inside the critical 8 and drill down so that we can get to predictability, training, and other actions to really begin to move the needle and try to. And then safety observation reporting. This is something we now require every one of our field employees, our professionals in the field. I think it's 5 per week. To make a safety observation report and relate that into the critical 8. So these are the critical 8. I'm not going to read them. I think there should be no question about what they mean. They're all high risk items at work, categories of work that we perform day in and day out. I'm going to drill down on just one to pick on it to give you an idea of what we do with this. This is trenching and excavations, as you can see on the right. I don't expect you to read all that. It's kind of like an eye chart, but there are 4 controls, and I'll read them quickly. Control 1, implement utility strike prevention measures. 2, evaluate excavation trench prior to entry. 3, provide safe access and egress. And 4, provide appropriate cave-in protection. And then under each one of those controls are unique actions. This is how we look at each of the critical 8. When we train, when we do safe plan of actions with our crews every day, the expectations of our foreman, our trade foreman. Look at what you're doing and think about these things. When we have an incident, we record our incident on a app that we have originated in our company called Safety Suite. And you have to fill out an incident summary report. And in addition to filling out what the severity level of the incident was, and we're now putting near misses into this, and even our safety observation reports at 25, we're moving forward to do this. But the algorithm inside this program will evaluate the level of treatment. It says whether it was a SIF, a serious injury or fatality, or potentially could have been, or a non-SIF. How was the critical 8 involved from your report, and whether the controls and then some of these actions were in place or not in place. And from that, the algorithm then spits out, it does a numerical scoring, and it spits out a minor, medium, major, or severe. And as or more important than that, it then says, here's some actions you should take immediately. It could be as immediate as this is really severe, stop the job, have a full workforce stand down and talk to the workforce. It could be bring the crew in, bring the foreman in. It could be bring the owner of the subcontractor involved in our group, CEO, to have an immediate sit down and talk about what happened, whether it was a near miss or an injury. And so, again, we're collecting data as we go inside the critical 8 for predictability and training, and where needed, even disciplinary action. So beyond the work, at this point, I thought, well, I could spend some time and talk a little bit about some of the very interesting technology that we are piloting and where we intend to go with it. But I decided to go the other direction. I want to talk about this mental health issue because I think our industry is just now coming to grips with what does it mean? What can we do? And it's hitting a softer side of life, as I said earlier. This mental health and relationships and understanding how to deal with this human interaction is not rules and tools. and it's a little tougher for us. So we have to recognize that if we're going to move forward. Ed cited some statistics, and they're alarming. 5 times more suicides in construction than at work. I think you had 5,300 workers. I may have a little different data set, but it said 6,000. If we had a little over 1,000 people die from fatal accidents in construction, I think this is 22 data. We had 6,000 or near 6,000 from suicide. So if that doesn't alarm everybody in this room and make you say, we need to get better, and what can we do? Quick note about what we're doing, and I'm not going to read all this to you, but I want to give a shout out to Brendan Bechtel Corporation. Brendan put together a CEO advisory council. In fact, they met for their second or third time yesterday in New York City. Brought the group together to say, let's look at this. Let's be aware of what's happening. What can we do? How do we affect our companies? How do we affect the industry for the better? And so that's working behind the scenes right now. One of the things Clark did immediately is we learned about the LEARN technique. And for those of you that don't know that, I'd say go online. It's a fairly simple an awareness tool, and it doesn't train you to be a mental health counselor, but it's pretty easy to think through it. And I think it's look at what's going on around you, empathize, talk to people, the workforce, where they are, ask some questions directly about suicide. If you get a sense there's something wrong, remove danger, remove bad objects if there's something that is of harm, and then next steps. If your sense is there's something wrong here, the next steps are get them help, get them professional help, get them to a clinic. And I want to, excuse me for 1 second. We trained approximately 25 mental health first aid folks in the company. And I want to say 2 or 3 weeks after we had this training, we had an incident on a job where a worker came to work, shared with his crew that his wife had left him 2 or 3 weeks prior and that his mother died a couple days prior. And he started to talk about suicide and how he had planned it and how he was going to do it on our job. And this immediately, the call, the recognition, the awareness, the call went to one of our first aiders, and they immediately went to the job, sat down, talked to this individual, and it was for real. It was a real dangerous situation, and they got him next steps. They got him to a clinic, got him professional help, and he's happy and alive and part of all the force today. So this is real stuff. And back to the beginning, talked about 20,000 people in our jobs every day. There's going to be a certain number of those people who are going to suffer mentally or have issues, and we need to learn to be aware and not look the other way. Every one of us needs to think about how do we relate to the people, how do we have relationships. And the last item I'll mention is we are now we're thinking through, doing some more research, and how do we train every person in our company, especially those in the field who are on the first line, to recognize these issues as they come up. And so very much where we all need to be thinking as we go forward, in addition to the technologies, which are really important. So we talked about building a culture of care. As near the end here, I want to talk about looking ahead and what are we doing. I mentioned SOR's safety observation reports that are required of all of our professionals. And when we look at that data that is accumulating now, a large majority of those reports are focused on housekeeping. Okay, and they're focused on housekeeping not because we run sloppy jobs, but it's because that's what the eye sees. Okay, they don't see inside these critical 8 areas, categories. And so looking ahead to 25, the first bullet here, impact hours. We've got a program now where the senior superintendent or the safety director on the job site is going to take 1 hour every week, and they're going to take all the professionals on their job, and they're going to walk, and they're going to talk about what they see. The more tuned, the more trained eye. What do they see on the job? And we're going to begin this repetitive training as to open people's eyes to the real risk categories beyond what is the obvious. And we think this is going to begin to help. And then these safety observation reports are going to be incorporated into our data in the aggregate way with the critical 8. Last 2 bullets I want to mention quickly. When we do project development pre-construction, whether it's a pre-bid or in a lot of cases we're working in a design build job or a CMR job where we have a lot of time with the designer, we may have 6 to 12 months before the shovel's in the ground. One of the things that we're going to now do much more concerted effort at is planning safety and getting the safety director, which largely start our projects when the shovel's in the ground, getting them assigned to and part of the project development. Are there items of work we can take off the job site for prefabrication? How's the ingress and egress going to change as the phasing of the project changes? How we gonna rig and hoist the job and crane the job? And so we're getting more focused, responsible people to think about safety earlier. We think this is going to serve to improve the thinking and the recognition of hazards as well. And then the last one I want to mention, because I think this is key as well. When I walk a job with a superintendent who he or she has, it's clear, they not only know the name of every trade foreman on the job, but it's clear from the interaction, there's a relationship there. They know each other. They care about each other. There's an accountability to each other for the way they're working and the quality of the job and the safety of the job. Those jobs have a very high correlation with the safest jobs. So with that in mind, we look at our young people. We hire 200 plus people out of school every year, and as they work in the field, they may be a mechanical or electrical coordinator or some specific part of what we do. We are going to encourage and push and pull so that they have relationships with the trade foreman. If you're a mechanical coordinator, you need to know the plumbing foreman and the sheet metal foreman and the pipe fitter foreman, because I think where we grow these relationships, our folks are going to get a lot of really important feedback and wisdom. There's so much wisdom from the craft in the field that we just don't know when we come out of school. And over time, we'll begin to recognize more. But where we can grow these relationships, I think we're speaking to this culture of care, capturing hearts and minds, and we will emulate some of the better statistics we have where our superintendents know everybody on the project. So that's a little bit about where we are moving ahead. This is a picture of a standout. I'm not sure whether that was during Safety Week, which we do on all of our projects, where we talk to everybody on the project. This could have been the result of an incident on the job where we felt we needed to stop and talk. But this is a little bit about what we do, and we do these periodically on our projects throughout the country. And then I wanted to end with a little bit lighter note. I have one of my grandsons who is obsessed with construction and with construction safety. And as you'll note there, this 5-year-old is always the hit of his neighborhood because he has all the gear. He knows what it is, how to use it. And now we don't have a helmet on him because we don't have children's helmets with chin straps. And he complains because with this hard hat, he can't get what he calls ear muffins. We haven't corrected him because it's cute to hear ear muffins, but he can't get his ear muffins over the hard hat. But he does have he has his orange ear protection. He's got his eyeglasses on. He's got the safety cone to warn people there's a little hole being dug, and long pants, work boots, and looks like he has his daddy's gloves on. So with that, I want to wind up here. See if there are any questions. I don't know how we're doing time-wise here. Do we have time for a question or two? Or
Be done by technology to reduce the physical strain on these workers, because average also age for retirement for construction workers is in their mid-40s.
Well, thank you for asking the question. And if I had the answer to that question, we could do great things in our society, but I think you really hit the heart of the problem in what you said. I don't think there's a person in this room probably who hasn't been personally touched or knows somebody who's been touched by drug abuse and a problem in this country. I know I do. I had a nephew that got wrapped up and ended up dying with drugs. I think we as a precondition to projects drug test. We want to make sure, and we want subs and we want folks on our jobs that have agreed that they're going to drug test so that we can be a first filter. That doesn't solve the problem. I think you hit on it with construction's hard work, and it results in pain, and it results in care, which leads to drug addiction and people who are influenced by these drugs that they're on. We need to be aware of that when they're on them. We need to keep them out of harm's way in terms of operating equipment or where they could do harm to other people. I think this culture of care where we need to have relationships with people around us, and when something's not right with them, and it could be that it's a drug addiction or they're under the influence of something, we need to be aware of that, and we need to talk. We need to expose it. I think there are programs that we try to get our people into for drug addiction and for pain medicine. And I think awareness, it starts with awareness and awareness of those around you. And I don't have the answer. I don't have a great answer for that. I think it starts with the recognition, which you just did. And then we all need to be present and to push the envelope as to what can we be doing to work with that problem.
I don't have an answer either, but maybe we should expand the definition of safety from incidents, accidents to how much strain we're putting on bodies and how much stress we're putting on mentally. So that's one of my pitches here.
Yeah. Well, I think the other aspect of what you said, I think it really is well taken as well. And we do constantly work on how can we, add mechanization, or how can we take some of the labor intense work off the job for prefabrication work in a factory, or bring some kind of mechanical means. And that's certainly something that we as a group need to continue to think about. And we are making advances there. Unlike a lot of companies, we have a small R&D group. And they're at any one time, they're looking at some of these things that can come from anywhere in the field. Somebody may have an idea, and we've processed some things and done some things to eliminate some hazards, but there's a long way to go in the industry.
I don't want to take too much, but I know many companies have smaller R&D groups, and we as academic institutions, we do research. So I think that's a great partnership opportunity, because you have the data and the real world problems, and we have the resources to do the research. Just leave it there.
Great idea. Thank
you. Okay. First of all, thank you for your talk. Very, very enlightening. You touched upon cost, and you always see these posters, safety pays. And I have a two-part question. One is, does Clark track the cost? And number two, if they do, what's saving? What are the savings percentage-wise? And that could be in many ways. That could be in workman's comp rates. It could be in productivity. Could be in lost time, et cetera, et cetera.
Another great question. I don't know that I have these specifics for you, but we do track costs. We have a lot of self-insured programs, and I want to start by saying that we don't make the safety obviously about cost. It used to be, go back to where we were 40 years ago, 30 years ago. And there was this great animosity of the field that, do you want quality, do you want safety, or do you want high productivity and lower cost? And nothing could be wrong. And if there are people that think like that, they're wrong. Or do you have a well-planned job and plan not just from how you're going to build it, but from a safety perspective, a quality perspective? Well-planned jobs are safer, higher quality, and lower cost just to begin with. So there should be no notion that safe job is going to cost you money. It doesn't. Well-planned jobs are better jobs all the way around. Now, we have, as I mentioned, we're self-insured largely, and we do track them on a regular basis. And we obviously try to save money by eliminating risk and lowering the incidence of lost time and recordable rates. And there's a high correlation. I can't give you the number. I mentioned cost with regard to the hard hats to helmets, because in the beginning, we were trying to push the helmets out into the subcontractor workforce. Those helmets were very expensive because there was one maker, and that was Kask. And I don't remember now, but they were, Devin's here, he may know, they were upwards of close to $100 a pop. And we gave out, I think 1,500 of them, which was a significant cost, but it was our commitment to say to the industry, don't make cost the issue. Now, I'm happy to say there are many manufacturers now that comply with the ANSI standard for OSHA, and the costs have come way down, so that should not be a barrier. But if you think about it on a very granular basis, and you think about an individual whose hard hat would stay on and eliminate a traumatic brain injury, not only do you think about it from a qualitative point of view for the life of that person, but if that person could not come back to work and ever earn a living wage again in construction, you think about if you spend $100 on that hard hat, how much savings were there? If you'd like, I could probably look at the insurance savings. It's probably something that's fairly closely held, but we do track that.
Yeah, it's not a question. I just wanted to say that several years ago, the Construction Industries Institute, CII, published a bunch of papers, which includes a way of calculating how much you save by implementing safety and reducing the number of incidents that occur, and also a little bit about the cost as well. So there is in the CII literature an answer to your question.
We've got a number of products that are being piloted right now, and I'll just pick one as an example. In our road crews, we have a pilot going on. I forget the name of all the softwares, frankly, but where we're doing road work, we have a situation where we have a crash attenuator. Obviously, you're supposed to be working on the safe side of that, but we have a series of 5 cameras, and those cameras are recording all the motion of the workforce for the entire day. At night, that data is uploaded and there's an AI element to it as well as an engineering element to it, because the AI is learning. And so every night, somebody reviews the tapes of the day, and they point out all of the unsafe acts. Something as simple as, are you working without your glasses or hard hat on? Did you personally enter the restricted zone, this unsafe zone? And from that, both the engineers are looking at that as well as the AI is learning about that. And then there's an email sent to the superintendent every morning so that here are the things we saw yesterday. Sit down with your crew before the start of work. That's one. We're not, using that wide scale yet. We're working on that. And a related one is, and again, on the work crews, there's, I think it's both LiDAR and radar that looks back at the lane that we're working within, again, behind the attenuator, but we're looking at cars. Did they move over? Are they approaching at a fast rate of speed? And if they are, there's some defaults set where there's visual, so the car can see that, as well as an audible, so the workforce can hear that. And so those are 2 examples. There are many more that we are looking at right now, and we maybe can talk a little bit more about as we go on. But thanks for that question, and that's something we should be pushing at as an industry, because I think there's a lot of good could come of that. Thank you.
All right. Hello, everybody. First of all, thank you, Bill, for your insightful and inspiring presentation about safety in the industry and the Clark story. First of all, my name is Kyle Ravale. I'm a senior studying civil engineering with an emphasis in construction management here at USC. And Mitch and I are here to share these conversations with you today, and I see we're already ready to kick that off. So we're just here to help you guys keep on track.
And as Kyle said, thank you everyone for being here today. It's a pleasure to be with you all. My name is Mitch Kirby. I'm a junior studying civil engineering in my undergrad and mechanical engineering master's degree. So our next speaker today is Dr. Iris Tomelin, a distinguished expert in construction engineering and management. She's a graduate of the Free University of Brussels, where she earned her master's and PhD from Stanford University. She is the Roy W. Carlson Distinguished Professor at UC Berkeley and a founding leader of the Lean Construction Institute and the Project Production Systems Laboratory. Dr. Tomelin is a member of the National Academy of Construction and has received numerous awards, including the 2024 ASCE Construction Management Award as its first female recipient. Please join us in welcoming Dr. Iris Tomelin.
Hello, good morning, everyone. It's a real pleasure to be here. I also wanted to thank the National Academy of Construction at Gibson and Burshin's program to host this event. I think it's super important to talk about safety, and I'm very excited to talk about safety in education, and then looking forward to the rest of the meetings we have today to learn from one another how we can better teach safety in our classes. Let's see here. I didn't get instructions on this. Queuing button. All right. It's very difficult to get to all the richness of Bill Calhoun's presentation. He really set the stage beautifully for what we need to talk about today, and I think he touched on just about everything we need to talk about. So some of what I'm going to say is repetition, but hopefully it will help focus our attention as educators on what we may want to teach our students. So I wanted to start off with the hierarchy of controls, which I'm sure you're all familiar with, a very traditional perspective on safety. It's been around for a very long time, became very popular, I guess, or widely used in the 1970s after OSHA was established, and it provided a framework to think about what we can do to enhance safety performance in construction. So at the lowest level, of course, we have wearing PPE, protecting the worker. We can implement administrative controls, changing the way people's works, look at engineering controls, isolate people from the hazard, substitute, replace the hazard with other ways of working, and then ultimately elimination. And I very much like this framework, except perhaps that I feel like it's a little bit distant. It's perhaps a little bit paternalistic, if I may so say, because it kind of projects this external perspective on how safe work is performed on a construction site. And of course, safe work needs to be performed by everyone at every time, and not just in construction sites, but also at home and in everything that we do. The 1970s perspective also very much amplified the importance of having management leadership involved in safety. Among others, my research advisor, Ray Levitt, and Nancy Samuelson wrote a book on safety performance in the construction industry and really highlighted the importance of management commitment to safety and how that commitment really needs to be present at all levels in organizations. So starting from there, it's a very exciting time actually to be in the business because we do have a lot of information technology tools. I'll say a little bit about that, and then I'm going to stop talking about it in the rest of my talk because we have a lot of more to say about it later today. But there are commercial companies, of course, available today that are very much like many academics interested in using artificial intelligence and sensing and vision and so forth in observing how work is being done. Again, perhaps a little bit of a paternalistic view, as in we're going to surveil our sites, we're going to observe what happens, and then we're going to try to implement corrective actions. That one company uses 360 cameras or robot dogs and have them walk around the construction sites, and then from these 360 images, they extract what they see, and they can identify hazardous situations, for example, electrical cord that is a tripping hazard, and they can highlight this and report back to the construction team on a daily basis. Here's what we saw. Consider doing something about it. So I think this is brilliant. This is very necessary. It's very useful. Obviously, if people don't see what needs to be seen, then artificial intelligence can very much help us see what we don't see. But I think from an education perspective, we need to really educate everyone, including our students, in learning to see what happens. And what one person sees isn't necessarily what another person sees. So taking the opportunities to go and observe what happens and analyze what happens from different perspectives is going to be super important. It was mentioned earlier today, I think it was Sinch's comment, that maybe we need to take a broader perspective on safety that also looks at chronic pain and chronic illness. I'd like to take our view on safety maybe a little bit broader even by saying, well, safety is all about doing work. So it's inevitably tied to production, and it's, of course, very much goes hand in hand with quality. And ultimately, I think this is what our workers do, right? We want to put work in place. We want to build quality products. And yes, we want to do it safely. And yes, we want to do it productively. But my mom always would say, nothing ventured, nothing gained. And if you don't do anything, you won't do anything wrong. And I think from my perspective as a lean thinker, this is very much the case in any kind of situation that we have, whether we perceive these situations to be safe or unsafe. Anything you do when you cross the street, if you don't cross the street, you can't get run over by a car, right? So we have to do things, and we are going to be exposed to situations where things can go wrong. So from a lean perspective then, recognizing that when you do something, things will go wrong, our keen interest is to understand what is acceptable performance and what is unacceptable performance, whether it is safety, whether it is quality, whether it is production. And there will be boundaries put on performance. And we like to have ways to try to reduce the range of variation on anything we do. And so it is one way of thinking about lean construction. The one way of thinking is lean is about identifying variation in production systems, in the way we design and make things. Some variation is good variation. We like to see different buildings because we have different requirements for our buildings. We like to eat different foods. We like to have, we watch different movies, whatever it is. There's a lot of good variation in the world. But by definition, if the variation isn't explicitly recognized as good variation, it's bad variation. And therefore, we need to go reduce that variation. Again, whether it's safety performance or chronic pains or quality performance, or deviations from performance standards in terms of production rates, schedules that aren't met, budgets that are not met. And so with that broad view then, we can begin to think about what we call a lean construction framework. So the way we think about construction is very much mirrored by this image of building a house. You have to build a very good foundation. Again, your foundation needs to be stable. If you don't have a stable variation, if there were a lot of variability in the quality of your foundation, you would not be able to build a good building on top of it. Then the building has walls, had openings, and ultimately it has a roof on top. And this is a segue into talking about a lean construction framework that's very much based on the way Toyota has been designing and building cars, what ultimately informed the formulation of what is called lean construction. So lean construction was informed by the lean manufacturing world, and lean manufacturing basically recognized that there are different ways of designing and making things. And a big study in the 1980s of the automotive industry recognized that specifically Toyota Motor Corporation was designing and making cars in ways very, very different from anybody else in the world. And in fact, they were so good at designing and making cars that they gained a tremendous amount of market share in the United States to the detriment of the large automotive companies in the United States. And so in the 1980s, studies were conducted to go figure out how they were designing and making things. And one of the researchers at MIT coined the term lean to say, we're not talking about mass production, we're not talking about craft production, but we're talking about something very, very different. And the very different is we want to do what the customer wants, understand value, we want to do it in no time, and we want to do it with nothing in stores. So that's a second definition of lean, besides understanding variability, good variability, and bad variability, and eliminating variability. And the reason why I bring all this up seems to be perhaps a little bit of a deviation from what you might expect in a safety talk. But the reason why I bring it up is because, from my perspective, I think we really need to teach our students systems thinking. It's very difficult to make an improvement in one location and expect that therefore the whole system is necessarily going to be working better. Sometimes an improvement in one location, in fact, is to the detriment of what happens in other parts of your production system. So for me, the House of Toyota, the lean thinking has been very beneficial. And I've been working for almost 30 years with the construction institute, with the construction industry, to implement lean thinking and to bring it into the industry. So we founded in 1997 the Lean Construction Institute, brought together many contractors, owners, designers, subcontractors, suppliers, to really think how we can improve the production system, how we can improve how we design and make buildings and tunnels and healthcare facilities, and so forth. And so with that in mind, with that theoretical framework, I wanted to briefly talk about where safety fits, and then give you some example on how we teach it from a lean perspective. And again, I think there'll be many concepts that resonate with what you already know and what we've already heard earlier today. But I think the advantage of putting it in a framework is that students will understand that there is a lot to do in many different aspects in how we design and make the ultimate products that we deliver to our industry. Right. So I already talked about the house that needs a level foundation, that needs a stable foundation to build on. On the left-hand side of this house, we have the just-in-time pillar. Many of you may know lean production as just-in-time production. The idea of just-in-time is exactly that. We want to be there at the time that we said we were going to be there. We certainly don't want to be too late, but also we don't want to be too early, right? So again, we want to be reducing variability. We want to improve the reliability in hitting the targets that we set out for ourselves. And of course, just-in-time has to do with planning, moving forward, executing work. So there are many concepts there related to takt time planning, for example, that are now widely implemented in the construction industry that have to do with exactly increasing this reliability in executing work, defining clear handoffs, and moving forward at great speed, while at the same time, if the just-in-time, if the planning process describes moving forward, going forward, of course, when something happens that falls outside of our range of acceptable performance, we need to stop. So the counterpart of the just-in-time pillar is what we call the Yudoka or the automation pillar. So just-in-time is the go pillar, Yudoka is a stop pillar. So in this stop pillar, we basically say, let's pay attention as we move forward to any, whether it's an incident or a mistake that happens in production. Let's identify these incidents. Let's identify the mistakes as early as we can. And as soon as we identify them, we must act on them. So back to the example of using artificial intelligence and giving rapid feedback to the crews. Obviously, this is super important, right? Rapid feedback, stop the production line, identify what happens, and then move forward. But from an educational standpoint now, again, is how do we teach our students what should happen and how they can not just observe that there is a situation that is outside of the limits of variability, but what can they do about it? Because our students are engineers, our students are designers of work processes, potentially. And so can we influence them? Can we teach them how to better engineer the work as it is to be done? So on this right-hand side, we have the Yudoka pillar. In the lean language, we talk about error proofing, but I would also call it like incident proofing in the context of safety, because, I mean, ultimately, as you see at the top of the house of Toyota, we're interested in best quality, lowest cost, shortest lead time, best safety, and high morale. And really important also to point out before I move on from there, in the very middle of our house, of course, are people, right? We're very much focused on people and teamwork, and we very much focus on continuous improvement. And of course, waste reduction, waste being anything that the customer is not happy to pay for. All right, so moving on then to talk about Pokayoki or mistake proofing. This is a theoretical framework that I actually found in the literature and then have been building on. The theoretical framework describes how work gets done. So imagine a work operation, whether it's placing concrete or erecting steel. The work operation has a certain description of what the work is that needs to be done. Then we get to human functions required. People get involved in doing the work. They have to use memory. They have to use their perception, right? See things. They have to be agile and dexterous to do the work. And then an incident might happen, right? An incident being an undesired deviation from the standard. It could be a positive deviation or negative deviation. So an incident happens. After the incident happens, we may be able to detect these abnormalities, and ultimately these abnormalities, if they're not stopped, they may turn into effect. So in the language of safety, we talk about incidents. If the incident is caught right away, it may be a near miss, and if it isn't caught right away, it's allowed to progress, it may turn into an accident, right? In the language of lean, we talk about mistakes that would happen. We can recognize that there's an abnormality, again, maybe a quality deviation from the standard, and ultimately the mistake might turn into a defect. So for us, the distinction between the moment that an incident happens or the moment a mistake happens and the time by which then it becomes an accident or the time by which it becomes a defect is a really important time difference. And let me give you an example. It may be that I'm walking on a site and then I stumble. The stumble, of course, would be an incident, something that's not supposed to happen. I'm supposed to be able to just continue to work. But if I'm quick, I can recover and not fall flat on my face. So that's the detection of the abnormality and the immediate correction. If I'm not able to respond in a timely fashion to the near miss, then it turns into an accident. I fall flat on my face. Does that make sense? So with that time frame in mind, I think conceptually it's really important to make the distinction between the moment some abnormality happens and then the ultimate outcome of that abnormality happening. It's a thought from Shigeru Shingo, who basically said, we can have zero defects in all production systems. We can have zero defects, meaning here, zero accidents. But he also recognized that to err is human, mistakes will happen, and likewise in my framework, incidents will happen. It's very maybe overly ambitious to think that we're going to eliminate all the incidents. But what we can do is eliminate or at least detect all the near misses as soon as we can. And then, of course, avoid all the accidents or mitigate whatever impact is being felt by taking precautionary measures. So let me give you some examples and then I'll explain some more about this framework. I actually have developed for teaching purposes a deck of cards. It's a little bit of a poker game, poker-sized cards. And what these cards show is different examples of safety practices or quality concerns that we have in our industry. So these are just three of the cards. We already talked about hard hats earlier. What does a hard hat do? Let me go back. What does a hard hat do? If we think about work operations and the occurrence of an incident and when a hard hat is actually effective, right? When is a hard hat doing its job? Of course, we need to wear hard hats from the moment we enter a construction site. But when is a hard hat doing its job? A hard hat will protect you if something gets dropped and falls on your head. It's the something gets dropped and fall on your head that I call an incident. Or, if you hit your head against something that's a low beam, for example, I would call that an incident. And what the hard hat then does is it alleviates the impact of the object falling on your head. So it alleviates the effect of some unwanted incident occurring. Likewise, tool lanyards are a good example. Tool lanyards, of course, are very good safety devices. Again, if we think about what the concern is that they address the fact that somebody may accidentally drop their tool, and especially when they're working at elevation, it could be very dangerous for people underneath, but also they could just break the tool and need another tool. So lanyards basically kind of catch the tool if a worker drops it. So back to our framework again, using a lanyard it's obviously useful, but it's only useful after the incident has happened, after somebody has let go of the tool. That's when the lanyard is doing its job. It turns out that there are very many safety practices that relate to alleviating the impact after an incident has occurred. There are many fewer safety practices actually in the upstream end of this framework. But back to the example of the AI detecting a power cord, let's think about what we can do to alleviate the occurrence, to reduce the occurrence of tripping hazards. So clearly, if the concern is that you have a power cord and you might trip over it, or that it might get frayed and damaged and electrocute somebody, a countermeasure would be to eliminate the power cords. right? So battery power tools in that sense are very helpful because they make the chance of tripping, they make the possibility of the incident totally going away, right? So in our framework, we distinguish the right-hand side, which are the methods that will alleviate the impact after the mistake has occurred, such as wearing a hard hat, using lanyards, using rumble strips, whatever the examples are. And then on the left-hand side, we have the methods that we can deploy to make the occurrence of mistakes less likely. So this is where a power tool goes on the left-hand side. Another example of a concern, a manhole cover. Manhole covers are very heavy. You have people working underneath of them. Obviously, the concern is if you put this manhole cover over a hole, if that manhole cover would fall into the hole, it would be very hazardous for anybody working underneath, right? The nice thing about manhole covers is they're round, and the opening underneath is round. Round lids cannot fall at all in the round hole. There is no way that you can get it in there. So in terms of addressing the concern that this manhole cover would fall in the hole, to me, this is the perfect way of mistake proofing, right? Nobody can ever do it wrong. It's the safest way to proceed. And of course, we have many examples in the construction industry as well, where we have openings through slabs that need to be covered, and we will cover them with some kind of plywood or hole covers, whatever the methods are. The way we think about mistake proofing and reducing incidents is that every time that we are concerned that something bad may happen, we try to implement a countermeasure. But the countermeasure, of course, will hopefully address the concern that we have, but it's not going to address all the concerns. So I very much like Bill's example of a cask, and I should get a picture of a cask and add it to my poker game. The cask is a good example, right? So people wear hard hats. Obviously, hard hats are very useful. They're very useful to protect you against falling objects, but they're not great for people that fall sideways and the hard hat may come off, right? So they're not so good for side impacts. So we do a root cause analysis. We find out that they're not so good for side impacts, and then we make an improvement in implementation, and we move from using hard hats to moving casks. Likewise, in my round manhole cover here, you can put a cover over a round opening, and you probably will say, and you see it on any construction site, if just the cover is bigger than the round opening, we will be fine. It's true in terms of preventing things from falling in, but of course, if that cover is not secured, it now becomes a tripping hazard, and if it moves, if it slides sideways, we have a new concern that it's actually not going to be effective. So then the next intervention is, well, maybe we should secure it, as you can see on the right-hand side. Maybe we should find a mechanism so that we can lock this manhole cover in the hole, and it's not going to move. It's going to stay there even when people roll equipment over it or the like. So it's a way of thinking about identifying concerns and then addressing them with countermeasures. And our industry has been fabulously creative, as it turns out, right? These are not new ideas. People have been thinking about safety and production and quality improvement for a very, very long time. But what our students haven't seen is the richness of all these different examples. So that's the goal of our game. It gets to be a little bit more theoretical from there on. We talked about making occurrence of mistakes less likely, as with the round manhole cover, or alleviating the impact. Of course, they're all good to do. Although, as you can see here from the color coding of my mistake-proofing principles, the principles on the right, detection and mitigation, are much less desired. They're useful, but they're much less desired than the principles on the left on the incident, because they are only useful after the incident has occurred. And we really want to be much more preventive than that. So our framework includes 6 different principles. Eliminate and prevent have to do with how we actually engineer the task, how we conceive of what work needs to be done and the means and methods for doing it. We have two principles, replace and facilitate, that have to do with once people get involved, what do they need to do the work correctly? And then we have two principles on the right that have to do with detecting, observing the occurrence of abnormalities, and then ultimately mitigation. And so we have different cards to describe these different principles. Eliminate basically means don't do it anymore, as in replacing a corded tool with a battery power tool. You never can trip over a cord that isn't there. Prevention has to do with make sure you can never do it wrong, as in the round manhole covers. And then we can replace. So replace and facilitate are going to help people do a better job. And I think there's many kind of low-tech solutions to that. There's also some high-tech solutions to that. Again, more on the high-tech later today. But replace has to do with, instead of doing one thing, now try to do it in a different way, maybe with a slightly different set of tools. And facilitate basically has to do with cognition, right? It's catching people's attention and trying to make sure that people understand and fully grasp the task. And then after the mistake or after the incident happened, we have means to detect, much like, a rumble strip on the road, right? Why do we have rumble strips? Well, it's there to detect that maybe you're changing lanes and maybe you didn't intend to change lanes. And if you didn't intend to change lanes because you were falling asleep at the wheel, hopefully it will wake you up on time so that you're not going to run off the road. So detection, and then mitigation, again, the hard hats and the lanyards, a lot of safety tools. But as part of the framework now, as you begin to look at examples, and I have hundreds of them, we can begin to distinguish patterns, right? So color coding is a very useful practice. It's useful in design. So this all pertains to engineering design, as it pertains, it pertains to the designing as well as to the making. So we can color coding BIM models, which nowadays become very common. But we can also color code different objects on our construction sites. I don't think we do enough of that to create a visual workplace. Colored nail heads are a nice example for the carpenter to figure out what nails they need to use in certain locations. It's very easy to say, in this location I need blue nails, and continue to work with that. They're also very helpful for inspection, right? So after a mistake might have occurred, people can actually easily see, did they use the right length nail in the connection, or did they use a nail that's maybe not appropriate for what's needed in that location. And nails are a good example, because once they're nailed in, you don't know how long they are anymore. So some of these practices have to do with both the human functions required to facilitate, and then also have to do with immediate detection. So we have many examples. This, I'm sure, will be a familiar one for you as well. Color coding in design, color coding in materials. Again, color coding in materials here. Utility trenches may be buried in red concrete, so that if sometime later somebody begins to dig there, they will be alerted to the fact that there is an abnormality underground here, and we need to not dig into electrical power line or break a major drainage systems or the like. So what we learned from this, and things we can teach our students, is color coding is an effective way to help alert people to what the situation is. And so once they understand that, we can now generalize from there, and we can begin to think of color coding as a method like, I have this concern over here. I have to apply 2 coats of a waterproofing material. The waterproofing material that I have is transparent. How do I make sure that I have 2 coats of a transparent material? Well, maybe you need to color code it, right? Maybe you dye one of your layers in a different color, right? You can apply your first coat, and then you apply the other coat, and the color coding, you can see that in fact you have applied 2 coats. So this is a quality implementation as opposed to a safety implementation, as you see here. Burchin mentioned earlier also that many concerns that we have about performance in our industry maybe don't fall into the rules and tools mindset, right? This worker obviously is doing work in what is I think from an OSHA perspective, probably an okay situation, but you can tell from bending over that this would be a rather painful job, especially in the long term. And so we obviously need to pay attention to that as well as designers, as engineers, and people involved in construction. And again, there are countermeasures you can take. So this is an example of a facility where there was great concern with quality of welds. And they created a huge jig that allows them to actually turn these square columns, building columns. And the jig is set up so that the welder can always just stand up straight when they do their welding. There's no bending over. It's at the right height. And moreover, the jig allows that column to turn so that every weld that is made is actually made horizontally in the best possible position that you can do your welding, right? So again, people have thought about better ways of doing work, and I think it's very helpful for our students, and I think industry practitioners for that matter as well, to really begin to see like, oh, this is a concern that we've had before, and oh yes, other people have already thought about countermeasures, right? Why don't we implement more of these countermeasures? Working on ladders, obviously a very hazardous situation. Again, had to have some example. Many large general contractors nowadays actually don't allow any ladders at all anymore on construction sites because it is just too hazardous to work off ladders. So we use of scissor lifts and other equipment, as you can see here as well. But this connection actually illustrates, the right-hand picture illustrates two things. So one is, let's try not to use ladders. Let's try not to have these people work in the New York City steel high-rise construction and sit on the beams for their lunch. But it actually gets us a step further, right? And again, this is what we want to teach our students, and I think we want to teach our professionals. It's not just about how the work is done. It's, what is the expectation of the task, right? How did you design the work that needs to be done? And so this system actually illustrates that they have moved from welded connections to bolted connections for moment-resisting frames. Was very important in earthquake territory. And you can see that this structural steam beam simply is going to slide into position, and that provides a stable structure. And then the next thing they need to do is simply bolt it all down, right? So clearly replacing the traditional steel design with bolted connections with an engineered system like this one is going to make the job much less risky. And again, this is the kind of thinking that I think we want to promote in our students. Likewise, I've actually used my poker cards in a number of industry settings as well. We use it for lunch and learns and so forth to promote discussions around safety and quality and production, right? About work methods, design. I wanted to throw in just an example from industry practice, not one I was involved in, but I think it really illustrates how, in this case, a group of lean thinkers are really thinking about their work and collectively analyzing what work needs to be done and how do we do it, and is there a way to do it better? So Harman Glass makes very large glazing panels, glass panels for tall buildings. They did an event where they actually got together and identified, what are the concerns that we have in our everyday work for safety performance, for quality performance, for production. They did what is called a Kaizen, an improvement opportunity. And they identified, for example, that they use these massive glass carts to move panels that are 2,000, glass panels that are 3,000 pounds in their factory. And apparently, Virocon, a glass manufacturer, has a videotape. I haven't gotten my hands on it yet, but has a videotape that actually shows that one of these carts fails. Right? Now imagine you work in a shop, you have this cart, 3,000 pounds glass piece on it. What happens when the cart fails, right? So in their Kaizen, what they did is on all the existing carts that they had, they actually welded on dead man legs so that if the cart breaks, the whole cart would not fall over and certainly not be able to injure anyone. So this lean thinking is out there in the industry. I think there's a huge opportunity to bring it to the classroom as well. And we need to teach the methods to our students that they can implement individually. And then separately, I wanted to close with this slide. I think safety, quality, production, it's not an individual's concern only, right? It is a concern for teams of people, right? Accidents will happen in accident-prone environments. There's a lot of people working in the environments where we work. Everybody needs to have their eyes out for everybody else. It was already mentioned, we really need to teach our students also about teamwork, the fact that different people have different perspectives, that there are multiple performance indicators for how work is done well. We need to also teach our students about psychological safety, right? The ability of teams of people like this Harmon team to come out and say, let's together understand how we do our work, and then let's make improvements accordingly. So I'll stop with that. I know we're a little bit over time. If there are questions, please.
Welcome back, everybody. Hope you enjoyed your little break. We'll now begin our first panel discussion of the day with an amazing team of construction experts. So we have a special guest today who will be moderating our event, and that's Mr. Ken Arnold. A little bit about Ken. He has over 60 years of experience in facilities design, project management, and offshore safety. He worked over 16 years at Shell Oil Company and led a Paragon Engineering Services for 25 years. Since 2007, Ken has been a consultant to the oil and gas industry. He is a professional engineer and member of both the National Academy of Engineering and the National Academy of Construction, served on the Marine Board of National Academics, the Board of Society of Petroleum Engineering, and the Texas Academy of Medicine, Engineering, Science, and Technology, and the Gulf Research Program. Ken is a member of the Steering Committee of Global Energy Mentors, trustee of Southwest Research Institute, and is past chair of NAC Safety Committee. He is the co-author of 2 textbooks on production facilities and his top facilities engineering at the University of Houston and Technion University, and served on the engineering advisory councils of Cornell and Tulane. So we'll welcome Ken to the stage. And joined with Ken, we have Christopher Toomey from USC FPM, Elias from Penta Building Group, Robert Rodriguez from Bali Construction, Kevin Whitaker of W.E. O'Neill, Devin Carangella from Clark Construction, and Jose Alday from Turner. Please give our panelists a warm welcome.
The purpose of this panel is to have these industry representatives describe the culture of safety in their organizations, its importance, and what they would like new engineering and construction graduates to know about safety culture. Now, this was pointed out to me to be important at the last symposium that we had that was co-sponsored by the National Academy of Engineering in D.C. just 2 weeks ago, is that the new embed criteria now includes a criteria for safety. It used to just be teaching ethics. Now it says ethics and safety. Doesn't say much, but at least we got the word safety in there, okay, which is new. But ASCE has come out with guidelines for how to implement the criteria. And I recommend that for everybody. Pages 24 and 25 of the ASCE guidelines talk about how to implement safety culture and the importance of doing it. And in those 2 pages, they reference the proceedings of the first 5 symposium that NAC put on in 2022, 2023. So we're beginning to get attraction from ABAT, and that should be a reason why those of you who are in the academic profession should be interested in teaching safety culture, because it is, at least for civil engineering, it is a requirement now. Okay, now the way we're going to do this is I'm going to ask each panel member in order to introduce themselves and to provide their initial thoughts on how safety culture drives success of their company. And then we'll move on to a question and answer format. I have some prepared questions Unfortunately, they don't know what they are, but they're very bright people. I can tell just by looking at them. Okay. And then hopefully we'll have some time for questions from the audience as well. I hope so. We'll go as fast as we can. So, and the first question is, how does safety culture in your organization drive the success of your company? And, 2 to 3 minutes at best, but please introduce yourself.
Okay, I am Elias Brooks. I am not Rod Weber, as pictured on the slide. I am the younger, more handsome version of the safety department. And how safety culture is important to Penta. I mean, it's everything for us. It is kind of the foundation as to what we do and what we believe, and it kind of starts there. And everybody in our organization is involved with safety, from a project engineer to an intern to a project manager. It's never just the safety person. I am the regional safety director for Penta, but it's not solely my responsibility when I walk onto a project for safety. To be honest, in our company, that lands square on the shoulders of the superintendent. They are responsible for it, and they are the lead. My job is to really help them get there to make sure that, from a technical aspect, we're rocking and rolling. And so, everything starts with the safety culture for us.
Okay. How y'all doing? Rob Rodriguez. With our culture, I just want to bring something into focus. Every organization, success, failure, is built on its people. And we talked about people a few times throughout the presentations, very good presentations this morning. People are invaluable. They are the greatest asset, the greatest resource in every company. And so my challenge for everyone here, as we challenge ourselves as an organization, is empowering our people, growing our people, leading our people. People don't really care what you know until they know that you care. And that human element, it's just, we can't forget about it. We can have the best safety technology, we could have the best safety system in place, but if our people are left behind, if they're not bought in to that system, you're going to fail as an organization. So the efficacy of your company, the success of your company, it needs to be built on that foundational level, which is in our company, our safety culture. And so is your safety rolled up in your core values for your company, right? A lot of us, we would say that it is, right? But do people even know what that is? Do you even know your core values? We talk about the word culture. What is your culture? A lot of people refer to it. I think it was defined earlier in one of the presentations. Norms, values, and beliefs of the organization. Is that at every level of the organization? Does that new apprentice feel the same way as that 30-year superintendent? Are they looking at safety in the same way? How are we bridging that gap? We talked about continuous improvement. That's something that we've been emphasizing at Bally a lot over the last few years. Because without that continuous improvement, the numbers are going to stay the same. We saw that with the fatality rates, right? The numbers are just going to stay the same. So what are we doing to continually improve ourselves? And that's where that technology comes in, right? Using that technology to our benefit to make more informed decisions, to understand the trends and what's happening across our organization, to make things better, to protect our people every single day. Sorry.
They're excited about this stuff.
That's a hard one to follow. Hi, I'm Kevin Whitaker with W.E. O'Neill, Regional Director of Safety for them. For us, safety culture really is an extension of our company culture. It's a culture of caring. We care about the individuals. We care about the people who come on our job sites. So the way we look at it, the way I look at it is, if you're coming into our house when you're coming on our job, and we're there to treat you well and have a symbiotic relationship with our trade partners and with our people. And so the culture that we try to set is one of caring. And I think that drives a lot of our success, because we're building the relationships with not only the people in the field, but building relationships with those trade partners. And we're also building relationships with our clients, then making sure that we're trying to educate them on why we're doing things a certain way or not doing things a certain way.
Good.
Yeah, hi, I'm Chris Toomey. I'm the Vice President and Executive Director of Facilities Planning and Management here at USC. Somewhat different, because we are not a commercial enterprise. And so our approach to safety really has to span beyond construction to facilities maintenance, real estate and asset management, and all sorts of different other work and tasks we have. I would say that from our standpoint, a key driver of our culture, it has to do with a sense of leader accountability and really something that is non-delegatable as a leader. I consider myself the chief safety officer for facilities planning and management, though I wear many hats, and I have some people to assist me with that. That accountability is driven into our contractual standards, which need to be unambiguous, clearly understood, and also to be something that we do not consider violations of lightly, both in terms of the contractor teams who are going and working for those standards, and I have several of them up here, but also in terms of our teams who are providing that degree of oversight. So that consistency of standards, that leadership accountability, all those things we consider essential to driving and ensuring that we have a rigorous safety culture that is driven through the entire organization and the extended teams.
Good morning, everyone. My name is Jose Alde. I'm the project executive for Turner Construction. I want to thank you all for inviting me to this panel. And I couldn't have said it better than some of my fellow panelists. Safety is number one in our culture. We lead with safety. Every meeting starts with safety. We really try to, for every person, every worker that steps foot on our project, they are all leaders in safety. And we really try to drive that home with every person that walks on the project, that they have a key role in this, in the safety of our projects, that their voice is heard. And not only do they feel like they're cared about, because our goal is to get each and every worker on site home safe to their families, completely injury free, but also that they have a voice in our team, that they can speak up when they see a condition that is unsafe and bring it to our attention. And I think that resonates very well with our construction workers. That it creates a high morale, that they're cared about, that they have a voice, and we and in some cases we invite them to lunch and we want to hear what they have to say. So it's really an inclusive practice that we have with our safety. One of the key things that we have in our organization, and really the number one thing, is building life, and that means living injury-free every day. And that's something that we promote in our daily huddles. We promote a safe practice, and we make sure that we're constantly communicating and we're constantly on the same page with every activity that happens on the project. So it is the key to our success, really. Thank you.
Good morning, all. Devin Carangella, Safety Director for Clark. I assure you I will not fall off the stage. I know some of you are thinking this. And if safety was a priority, someone will be standing here and helping me. But I agree with everything everybody said, so appreciate that. Being a safety director, I get a lot of questions, right? And one of them is about safety and safety culture and all the conversations we have. But I agree with Rob the most that it's a core value at Clark. So we have, 5 core values, and safety is the first one. And the challenge we have with that is you hear about safety first, right? You hear about safety is number one. Has anyone watched the video by Mike Rowe? Mike Rowe that does Dirty Jobs. Has anyone seen the video called Safety Third? Okay, if you haven't seen that, watch Safety Third, because it really talks about how do you truly prioritize something. And I love that because it's a core value. So your priorities change, but your core values do not. And that's just the way that we approach it at Clark. And the last comment would be, we talk a lot about relationships, right? Well, relationships don't always have to be good. When you're in construction, they're not always good relationships. They're just relationships. So you get to know somebody. And I think I'm at an advantage because, Bill Calhoun with you, all of our programs, that we have a lot of programs, but with relationships, and a few of the photos, if you've noticed, on every safety helmet is the employee's name for all of our Clark workers and all of the trade partners on our job sites. And actually on the Clark vest, we have our name as well. Because if you want to have a relationship with someone and you approach them and you have a conversation, it says our name, my name, everyone's name at Clark, on 2 places, so that when you're talking to someone, you see their name and you can have an actual conversation. So I love that we did that in the last 2 years.
Okay, very good. Thank you. Now, I have a safety observation. Okay, for everybody. How many people in this room in your organizations have stop work authority for everybody in the organization? Raise your hands. Yeah. How many people in this room saw me standing up here in an unsafe position and didn't stop work? Did you stop work? No. Because it's very hard to stop work. When you're in a peer environment, just saying that we had stop work authority doesn't really mean we have it. Even when, we all believe in it. Everybody in this room believes in it.
I believe in it. And I was standing up there until I finally figured out this is crazy. What am I doing up here? Okay, so I just want to point out that safety and safety culture is a very difficult thing. So let me ask the panelists, and in no particular order, just anybody who wants to address this. We've heard a lot this morning about, it takes effort and therefore it takes money and resources to create a safety culture. Why should a company try and do that? What's the benefit? Anyone want to address that?
Well, like everybody said up here, if people are your best tool, right? This the most important thing in your organization, then people then are important, which means safety then becomes important, right? So for us, I think, a lot of people have already kind of mentioned it. It's about building relationships. It's also about caring, right? We understand that safety is really the value of caring. If you care about something, then you want it to be safe, right? That's really, if you kind of boil it down in a nutshell. The reason I tell my wife to wear a seatbelt in the car really isn't about safety. It's because I care about her. And since I care about her, then I tell her to be safe. That's why I went out and spent $1 million on a vehicle for her, because it was the safest one possible. But building those relationships is important, but there's a how to that, right? I think most people understand that you should do it, but how do you do that? Some relationships are good. Some relationships are not so good. We practice a series that we call Selling Safety. My boss, Rod, actually developed this and put it on. And I know it's kind of popular amongst a bunch of safety conferences. You've probably heard it before, but he actually has a sales background, and he goes through the selling process with us and makes us practice, role play it. Everybody loves it, right, John? Everybody loves doing this in our meetings. But it helps you really focus on what's important, right? Listening, understanding, developing a need, right? I know what I need as a safety professional, but as I'm talking to somebody, what do they need? And how do I find that out? And so that, to me, is about that culture, right?
Chris, you want to say something?
Yeah, no, I think that's all very important. So how do we look at it as an owner? Well, over 400 projects going on at any one time. Clearly, there is an ethical responsibility, the way I perceive it, to maintain a safe climate and a safe workforce, whether they are our employees or whether they are contracted employees. We make no difference between the two, and that accountability does not change. So, above any financial business reason, there's an ethical reason to maintain a safe environment. But then there is a business reason. We, at FPM, are always conscious, and we have owner-controlled insurance program for our major projects, about what is it going to cost us to have an accident, both in terms of finances and schedule. And can we invest in a company that is not considered safe? So one of our key selection criteria is, in fact, the safety record. And we have actually have several, one or two companies, won't go into names, who we do not work with anymore because they have not proven themselves to be safe, either from an accident or from a near miss and a perception. But then I think for USC, independent of the business relationship we may have with contractors, there's a reputational piece. We at USC do not want to be perceived as an unsafe place to work. I think it's very important that we're mindful of that, because we have a role within the greater community, both here in Los Angeles and in the greater academic community. So we really look at those three pieces as essential for why having that safety culture is going to be so important. And some of them transcend just us, but we look at it holistically.
Okay, let me go on. I think what we're hearing is safety is beyond safety rules and regulations. We can teach safety rules and regulations until we're blue in the face. But if we really, really want to impact safety, there's certainly safety in design, which we heard about, but there's also the idea of a culture that really creates safety in the ethical way in which you teach your employees and your contractors and subcontractors and everybody else on the job site. So now I want to ask another question. Okay, we're here about teaching safety culture in undergraduate and graduate education, okay, in education in general. So my question for the panel is, why should universities introduce concept of safety culture in the education? What are the benefits that you perceive from the university teaching these to engineers and construction managers and other degrees? What are the benefits that you perceive from a company perspective? And what are the benefits from a student's perspective? Why should a student care? How many students are here? Raise your hands. You got a whole bunch of you. Why should they care? Whether they're taught about safety culture, they're going to come to work for you, and you're going to create the safety culture. And why should they care?
I'll take a first shot at this. To me, coming out of college, if I understood the role safety played in construction, I feel like that would have been the competitive advantage just for me to be better in my career. It could be purely just looking at it as like, if I understand one massive part of the industry and I'm coming into the industry already having a good baseline of that understanding, you're gonna rise to the top pretty quickly because you will have that foundational piece of what a lot of other students don't have coming out of college. From a USC standpoint, you then become the college that is producing better engineers and better construction managers. Like you're helping build an industry from the bottom up, so to speak. That's why I think it's a massive upside.
For it, David. Yeah, and so I added that we're teaching students everything there is to know about construction, and we're not adding safety to it, where safety is what will stop any job. You have a safety incident, everything stops. So why not educate them on the most important thing in construction, which would be safety? We talked about earlier how every employee at Clark Construction has to make 5 safety observations a week. So whether it's 1 a day or 5 for the week. And we're starting to realize with our young engineers, they don't know what to look for. Like they have no clue. They're going out there, and that's why if you look at all our trending, we've made thousands of housekeeping observations and very little to do with material handling or, dropping objects. We got plywood flying off the 20th story of a building, in Century City, telling you too much happened. But we're not looking at securing plywood. We're looking at securing plywood. We're looking at, the cords and the housekeeping aspects when they really need to start getting engaged in it early enough and saying, all right, what is a critical risk? But what should we be doing versus, that trash can's.
Or Devin, it's the attention paid to PPE, right? Like everyone wants to pick the low-hanging fruit.
So, anecdotal, we started our observations, and we had hundreds of observations of people that were wearing pants. That was in the PPE section. So they evaluate PPE, and they were like, PPE is good, and they would make a positive observation on one of our jobs where people were wearing pants, because that was one of the observation criteria. Yeah. So like pants are in place. Like, no, we got to move beyond pants, but to like actual critical risks. So educating them early. Important stuff.
Yeah. I can't imagine a construction site where people aren't wearing pants, but that's okay. It should be interesting. It's unique.
If I just something to add to that, I think is something that's valuable for all of us, no matter what our role is. If you wait until a student gets to their organization that they're going to work for to start talking about safety, what does that show them? Regardless of what the material is. If you don't train it in school, if you don't speak to it in school, you're sending them the nonverbal communication that it's not really that important. Let that sit in. If you wait until they get to their company and say, hey, okay, company's going to do that for you. Guess what? We're already waiting too long. Okay? So, as was brought up a little while ago, I'm just going to say it, common sense is not as common as we think it is, right? So, setting people up for success, setting our young leaders, our future leaders up for success in that training program is essential. Thank you. Anyone else want to?
Well, I did want to point out that, it creates a foundation, having it taught in the university level, but we're never done learning about safety, even at our levels. It's a continuous growth, continuous improvement. And so I'm learning things as I go through my career as well. with the different challenges and tasks that we have in place. So setting that learning habit up early is going to set them up for success, definitely.
I just want to emphasize something that Ed touched on earlier. On your tables, there's this piece of paper. I hope everybody takes a sheet of it. It says, "Why teach safety culture concepts to undergraduates?" I'd really recommend you read it. Take it with you, read it. It talks about an incident where in Jack Tollner's early career, and I can tell you in my early career as well, we were young engineering graduates. We weren't construction management people. We weren't construction engineers. We were civil engineers. But the first thing our boss told us to do was go out and help supervise a construction job. Okay, I and he didn't know what to look for. We were both lucky. We had construction foremen around us, because that's the way oil companies worked in those days, who were knowledgeable, and it could help us keep out of danger and help us see when something dangerous was happening, even back in the early Middle Ages when I started. But with Jack, he had a friend who was in a class with him, one of the company classes, and then was assigned to being a construction manager. And he was so grateful to go out and be a construction manager. Guy's name was Ben Burns. And Jack kept thinking, I hope he has good, experienced construction people around him when he goes out. He went out on his first job. There was an explosion and he died. Okay. What was the explosion? Some welders were welding on a piece of pipe that had natural gas in it, and it blew up a tank. Now, that happened a long, long time ago, but I can tell you that 5 years ago, in what used to be called the Gulf of Mexico, there was a similar accident. A welder was welding on a piece of pipe. They hadn't checked it out, even though they had all the safety management systems in the world, and they'd signed off on job hazards analysis and safe work permits and all the rest of that. Nobody paid any attention to it. 3 people died when the tank blew up. We can't accept that as an industry. We just can't accept that. And the problem I helped analyze the accident I just talked about. The problem there was they had all the safety management systems in place, but there was no safety climate. There was no climate that said, this is important. When we fill out a job hazard analysis, let's think about the job. When we get a safe work permit, let's make sure the work we're going to do is safe. And so I just want to point that out to everybody. There's also in that attachment a list of our executive insights that NAC has put together that are really small. They're 2-3 page things. They're easy to read quickly. That can actually be a guide to how to implement a safety culture that you could teach undergraduates from. You could even teach graduates maybe from that as well. I'm not sure. Okay, I have another. Okay, next question for the panel. I'm done philosophizing. Okay, how have safety-related technologies changed your approach to monitoring and improving safety job sites? And how have they influenced your organization's safety culture?
Well, from FPM's perspective, what we use is really a cloud-based system for safety recording and safety analysis, which has really made things very, very productive for us. So I'll just use this as one instance. So rather than having, for example, a safety report generated, it has to go into the office, and people have to huddle around it. We have these things. We have them generated now very easily. They are handheld based, and we can get that safety information into people's hands as soon as possible in order that that information is used very rapidly. So I'll use that as just one example from FPM's perspective, though we have used robotics, which has helped us in things, particularly in some remote area of inspection, which has helped us great. So I'll pause there. I'm sure others have great techniques.
All right. How about some of the rest of you? Want to talk about technology and how it's helped you?
So some of the things that we've been using over the last few years, telematics. So as we all know, to get to these job sites that we're working on, our work areas across our operational environment, we've got to drive, most of us, right? And so some drivers are not as good as other drivers, right? So sometimes we need coaching. We need to understand what's happening on our roads because, frankly, when you have, a large truck full of equipment, it takes a little bit longer to stop. You need to have a little bit more of a passive approach to all of the other drivers around you. So when I say telematics, some of you may or may not be familiar with it. It actually pulls data as an individual drives, and it will use sensors and other things that are that's hardware that's included or integrated into the vehicle. And through those features, it will send us information about how safe that person is driving, whether it's hard braking or harsh acceleration or, turns that exceed a certain G-force, right? That could be hazardous to the driver. Now, through the same company, and this is becoming more common in the industry, they're taking that a step further to provide AI coaching and notifications when the system notices maybe there's a distraction for the driver, when their eyes are not focused on the road, or maybe there is fatigue that's setting in and someone's, dozing off, right, when they're driving. So those features are now available with those types of tools that are out there for people to use, and it's becoming more and more common. So those are some of the things that we're using.
Great. Devin, you had.
Yeah, I mean, there's telematics and there's the tracking and trending of all the data that we collect, but like a useful tool that we've adopted in the last year for utility strike avoidance is a rigid seeker SR24. So we're hitting a lot of utilities. We're hitting utilities, as many of you probably know what. We would install the utility or the 10 power, and then we would hit it, our own utility. So you go back and you say, what could we do better? Well, we talked a little bit about that, where you could use detective tape of some sort, but we're using like GPR scanning for all utility, right? So we don't hit an existing utility, depending on the as-builts. And then once the GPR, we have the drawings, but then we go back and scan it with an additional scanner. So before we start work, before there's any mechanical means of digging, we use an SR24 scanner. We have 2 of them on the sites here at USC, just to prevent all of the little utilities that we may hit, even if it's irrigation or a dead line, just to identify. And that's been a really useful technology. And make it mandatory.
And as you know, that everything here at USC is highly documented.
Both you and Turner are very well aware of that fact.
That's what was
It's always a surprise.
That was crazy because we would have these just elaborate 3D models of everything, but it doesn't matter how great the plan is that you're looking at. When the excavator gets on site, he starts digging, he'll tear through everything that's on the truck. It doesn't matter. You physically have to be there to observe what's there and be able to detect it. And the great thing for us has been, even if we scan it, right, and there's nothing there and we hit it, at least we knew there was nothing there that was potentially energized. So that's been really good.
We're using drone. So we'll do some inspections like QA/QC inspections or safety inspections if we need to with a drone. And so that the whole idea, if you go back to like the hierarchy of it needs, if you eliminate the ability for somebody to even be in an area where they need to be tied off, then you don't have the problem of them ever falling, right? So it was a little bit of a shift of mindset. One of our first projects we really started doing, we're building a hotel out of Disney. And my team wanted to get on a swing stage to be able to do the QA/QC inspection the next year. They called me up. They're like, hey, we need fall protection. I said, no, not at all. You guys, we need to be smarter. We need to figure out how to accomplish the same task without putting yourselves in harm's way. A little bit of resistance, but then after they started to see it my way, they were like, oh, yeah, we can use a drone. And now we're starting to use that as standard practice on a lot of larger projects.
One thing I was going to bring up, and this is something that's been implemented a while back as well, is hard hats. I mean, something as simple as a hard hat, the type 2 hard hats that we're really encouraging all our trades to start using. And even if they don't use it, we give them, we try to give them as much advance warning as possible that, look, if you come on a Turner project, you are going to be expected to use the type 2 hard hats. And for those of you who are not familiar with it, it is a chin strap hard hat. It's the latest technology. And as things get better through technology, we'll definitely implore something that's better. But I think about some of my times in the field way back when we didn't have those, and how I could have used one, because when you're climbing through a scaffold, or you're climbing through a ladder, or you're climbing through somewhere where your hard hat could essentially be thrown off, it's very important to make sure not only as a fall hazard, but that you're still protected. So that's a technology that's existed for the past year, but again, it's one of those things that's continuously improving. Just something as simple as a hard hat. The PPE technology is getting better.
Good. Okay. Let me see. Trying to remember what I did. This is a tough question. Given that we want universities to teach more about safety culture to the graduates coming out, how can universities better prepare new graduates to engage with the safety culture in the industry? What do you think from your perspective? I mean, we all know that everyone's curriculum who's an academic has no room for anything new. Okay, that's a given. Let's understand that. But we still want them to do this. So what is it? What's your recommendation? What should they be doing that you don't think they're doing that?
Yeah, we all have different experiences. I think mine was very much in the military. And when I used to teach at the military academy, long before any of these students were born, we tried to take every single class and treat it as if it was a military briefing, so that the cadets get very used to the culture and the environment that we're going to be in. I think as we look at engineering, and we'd have to look at every single class and what the variation would be. But you have to say to yourself, what is that job site culture? And we've discussed many aspects of that right now, right? I wouldn't say we run around in hard hats every day in class, but, there's PPE. There is, we've talked about safety minutes. I think an integration of those common things that they would be expected to see in the environment as the norm within the classroom environment takes the newness and the strangeness out of it when they hit the corporate world. And then they are faced with, well, yes, we've done this. I did this all the time. The number of new, when I was with other companies, the number of new employees coming right out of university, we had to actually take and show them how to put on the PPE. It was, to be very honest, many of the older hand workers they'd have a lot of challenges with the credibility stand of that, right? So I think taking these things and just integrating them within the classroom environment would not dilute what is being taught in the classroom, but would actually add a degree of the environment that they will be in.
I think also if you're teaching one of these classes, like reach out to one of us. I'm more than happy. Like personally, I'm more than happy to sit down and look at your curriculum and say, hey, like, here's how I would integrate it throughout what you do. Because it's not just a singular class. It's an integration through every step process. So I'm available.
Yeah, you kind of stole my thunder there. It's all good. I think beyond that is understanding that safety is a choice. It's a personal choice. You have to make it personal, right? And I think sometimes we blur the line between safety at work and safety at home. It's all the same, no matter where you go. And I think if we're able to relay that message, I mean, we have students in here. Do they talk about safety on campus? It's the same thing as safety at work. It's the same thing as safety at home. So inviting people in, bring that real world experience, I'm sure you can partner with some of your contractors here on site and do a field trip on their project. And so they can actually see what's going to be in place and how that then can affect people, right? I think that might be your best bet.
Let me just, this comes up at every symposium, by the way. The academics will tell you, we don't know how to get to the people, to the industry people, and the industry people will say, no one's asking us for help. So please Let's get that across. The industry, especially these 6 guys, okay, but the industry in general really wants to help by, invite invite speakers. There's lots of construction going on every college campus. Go take a field trip.
The best way for the USC community to get plugged into it is right through.
Yeah, and I wanted to just point out in relation as it relates to safety and just creating that sense of awareness and heightened sense of awareness, even at the university level, really a sense of urgency, really, because everything we do on a job site or we don't do can affect somebody's life or livelihood or family. I mean, if we don't take the courage to be aware of this, of how important it is to, and the courage to tell that person that they're performing an unsafe act, that could affect family and generations from years to come. I mean, everything we do on the job site as it relates to safety is so impactful and affects somebody so much more. We're not aware of it. So creating that heightened awareness. Yeah, I've experienced fatalities, not safety related, but those fatalities haunt me to this very day. So just creating that sense of urgency, that call to arms, at how important it is, even at the university level, to create that foundation is critical in it. But it just needs to be an increased high level of awareness that these are possibilities. And I love the stories you had brought up. I mean, I don't love the fact that how devastating that could be to someone's career, to their lives, to experience that, and for the people that are affected by it is so impactful.
I would add, like, create a routine, right? If we're talking about we don't have capacity or the curriculum won't allow something to be added, you could simply do a safety minute. We did a safety minute and we kicked it off this morning. We do that in business, in the industry. Why not do that in a classroom? And then ask all the students to rotate a safety minute, and they'll start getting more and more creative. And it's just now you've created, or you've embedded that routine in them to do a safety minute. So then when they get into the job culture, they'll hear someone else do a safety minute, maybe have something to reflect.
Yeah, we call it safety moments, but we all speak the same language. I mean, it's all the same thing. Really, it's just sharing that.
Okay, we have lots of students in the room, so I'm going to ask the next question. When hiring new graduates, how does the knowledge a student has of safety and safety culture specifically factor into whether you're going to hire them and your expectations and their future career?
Go ahead. One of you, start. I'll take it.
So I can't speak for all the interviewers that you guys will ever experience in your career, but I will say this. When you are effective with how you look at safety, how you live your lives, with your safe practices on the job site, with how you communicate, safety, as you will continue to learn, as we all continue to learn throughout our careers, it's a people game. How effectively you communicate with others, how effectively you lead by example. When you're doing that, it will set you apart from your peers. People will look to you as that leader without you even realizing it. And they're going to be like, wow, okay, they're going to do it. I think I can do it too. That will follow you in any organization that you go to. No matter what that organization's culture, if you are living it, if you are leading by example and setting the example for people around you, people are going to notice. So find encouragement, find motivation in that, because frankly, I can't, I have the pleasure of being up here with people that are very committed to safety across their organizations, but not all organizations are like that. Expect it.
Okay, anyone else want to add to that? Yes, all right.
So when we recruit, that's actually a part of the criteria. When we go to colleges and we hold career fairs, if anybody brings up safety during that recruiting moment or those interactions, our team notes it, like they'll write it down. You're to the point where I've gotten a lot of, like, someone said, oh, this guy's a nuclear engineer, but he's interested in construction safety. I'm like, he's probably just saying safety. But yes, so we have quite a few of our recruiters, all of our career fair recruiters look for safety during those conversations. Yes. And encourage all of you students that are looking for careers, include that in the conversation.
Yeah, same here. Safety and quality, to be honest. That's kind of the two things we're looking at.
And we kind of say tongue in cheek, but it's if you don't do anything else right in Penta, do safety right, and you'll be good.
Okay. Any other comments or one last question? How do you see the construction industry's safety culture evolving over the next 5 to 10 years? And what role will technology and innovation play in this evolution?
I believe safety is going to become ever more important because labor is incredibly expensive compared to material equipment. If you go to other parts of the world where we have been, you will find that labor is actually the cheapest or less expensive piece of the construction experience. In the United States, and in our area culture, rightfully so, it's the most expensive. So preservation of that labor and preservation to be able to hold that labor, because who would want to work for an unsafe company? I wouldn't. Is absolutely essential. And as that workforce shrinks in the trades, and the workforce in the trades is shrinking, it is shrinking. It's a demographic issue, but it's also, that we people don't want to go into the trades, or we have trouble getting people into the trades. It is shrinking. That preserving that, maintaining that, is going to become absolutely ever more important. I think technology will be a great add, whether it's wearables, and there's a whole lot of issues associated with wearables. I had them in the Middle East on these huge sites where you had to know where everybody was or they'd just disappear for days, whether they wanted to or not. But I do believe that technology will have greater and greater impact as that workforce shrinks. And we have a requirement to deliver at least the same, if not better, in terms of our product.
Okay, anyone else want to add to that? I think if we keep enhancing our goals and look for that continuous improvement, it's going to get better. I mean, speaking from my own experience in the past 26 years, it's changed dramatically. I think back to when I first set foot on a job site as a young recruit, and we didn't have to wear glasses or safety vests or gloves. And just seeing how it's evolved so far, I can only see it getting better, especially with technology. But it's going to come down to making sure that we set our goals. What do we want to achieve? Do we want to achieve a 0 incident rate? We can do it. It's just the matter of just putting the resources in place, being dedicated. And then, yeah, like Chris had said, the technology is going to enhance it, but it's really going to come down to setting that standard and setting those stretch goals. And what do we want to achieve in the next 5 to 10 to 20 years?
Okay.
Well, I was just going to say, I think in the construction industry, sometimes technology is a bad word because it signifies a change in habits and the ways that people did things. But realistically, technology is everywhere we go. As probably a lot of your students can tell you, AI is everywhere. And we are starting to use it in our implementation of JHAs, where a crew leader can actually speak to his phone, basically set up the day, what he's doing, where he's working at, the type of activities, and it'll basically write it out and organize his thoughts in a nice, concise manner. And it's helped our trade partners really think about what it is that they're going to be doing. So that evolution, it's happening. It's already here, and it gets better every day.
Just one thing that I think is important to highlight. A lot of our workforce, they either didn't finish school or they finished school and they really couldn't read that well. We have several foremen that taught themselves how to read in the field with their spouses, going home, working with her to help them to read. So just understand, as technology continues to improve, one of the reasons that folks are so averse to receiving that change is because the way that you and I might look at technology isn't the way that all your field force looks at technology. And so I just can say that as an encouragement for all the young minds and the future leaders in this room. Please, as we continue to modify and improve our technology that's in use across the organization, don't leave the folks out that really might not understand the simple things that you might think they understand. Does that make sense? So I think that's an important part of this.
Very good. Okay, we have some time left for some questions from the audience. If you want to question anyone.
Hi everyone. Before I ask my question, I just want to say I appreciate everything that you guys have shared from the industry perspective. I'm a graduate student at USC, and then I'm conducting a study that studies the impact of technology on health and well-being. It's on every table of the symposium. So I definitely, from the academic side, reach out to you guys individually about this study more. But going back to my question, I think you guys talked a lot about safety awareness, risk identification, how to build a safety climate more on an individual level. And I want to ask a question about team dynamics in construction. As we also heard from the previous presentations, people and teamwork are really essential in construction job sites. And I want to ask about how to foster this kind of climate change among laborers, equipment operators, foremen, superintendents. How do the daily interactions, the communications between teams, how do that foster how do you guys foster that through that kind of interaction, the safety culture? Sunny is not an engineer. She is a PhD student in occupational science, and she is working with us on this project where we're looking at teleoperation of demolition. I just wanted to say that because I think this is an area that is very interdisciplinary. So it's not just the engineers doing the research or engineers teaching, but here we have a demonstration of an occupational science student and her advisor being interested in this topic. I think we need to see this more and more so.
On that, great question. So one of the things that we do are daily muster meetings, where every week you bring all stakeholders together and start to talk through, hey, what is it that you're doing today? What are you doing? What are you doing? And at that moment, that's when you start to get the most bang for your buck. Like that's where everybody starts to, oh, hey, I need to get my material out of there. I need to do this. I'm going to do that. And then that's typically just going to be the foreman. And then from there, the foreman will then convey that messaging to their team and let them know, hey, this is what's going on. This is in our area. This is what we need to do. So that's one of the ways that we first start.
Yeah, it's actually a lean concept, right? The last planner meeting. And so that's just getting people in the room talking about what they're doing, how they're doing it, getting them to communicate. That helps foster that relationship between trades.
We regularly, I want to say every month on our job sites, we host a 5-worker lunch where we actually invite 5 representatives from the job site to come join us. It could be usually, I mean, we try to keep it within either a journeyman level or an apprentice level to really get their feedback and let them know, that we're interested in their opinions on safety, and we want to get their feedback. And the outcome of those discussions usually involves a group of suggestions that we share in these daily huddles, and we implement those with the rest of the team during our daily huddles and stretch and flex. So again, that's one way of us getting feedback. But in those huddles too, we really try to get some comments from the rest of the worker community.
Another thing we do is we actually do the job site safety committees, and we'll ask the subcontractors to provide not their foreman, but a journeyman, like their right hand, to be the representative for their company. And then we just get on a massive text chain, like WhatsApp or whatever it is, and they develop that relationship with each other because the idea is, hey, this isn't gotcha. This isn't a gotcha moment. This is hey, you got this going on over here. You probably don't know about it. Here's a picture. I talked to your guys. And then that individual should follow up with their email. Another way. Seems to be effective.
I don't know. Oh, yeah, that's on. This was really a fantastic panel, I have to say, for me. I want to make a couple comments and then I do have a question. One is Chris is the guy for us here at USC. He's got a huge organization, and I've never heard him speak about safety the way you did. So you're going to be chased by us, Chris. Sorry.
At my age, I'll probably be cool.
Yeah.
I also wanted to make a comment about how important I think the idea of us as academics bringing in industry is, and I do want to compliment my colleague Hank and the department. We're doing as much of that as possible, and I do think that's an important part of the solution. However, here's the question in the critique, which is, I think we bring a lot of industry people in, right? And what I've learned this morning is you don't know what to look for when you're new on a job site. And I'm never been on a job site really like you guys, to be candid, right? So I don't know what to look for. And that's emphasizing the importance of you guys actually coming in and telling us and telling the students what they should be looking for. I don't think it's an excuse to say there's no room in the curriculum, though there's no room in the curriculum. But bringing you guys in is actually easy to do for us to make the request. But you guys have to come, and there's people on the stage that come and offer us time all the time. The question is this: how would you like to be brought in with respect to the specificity of safety culture, safety practices, and in which kind of course do you think you'll have the greatest impact? Because we have 4 years of courses here, and pursuant to that, part of the question is, which technologies do you want us to be implementing in our curriculums and classrooms to really emphasize the issues in safety? Thank you.
And I'll start. I would do a presentation. I've done it a few times up in Sacramento State when I was recruiting for candidates out of their safety club. And I had a presentation that I would do on general construction safety, and it just terrified them. It was awesome. Because we go through all of these high hazard activities and explain the scenario. But it was entertaining and, kind of eye-opening for them. So I think in any capacity, as a safety professional, I would come to any group, and I think they would be interested in just the general construction safety. And then to your other comment about, getting involved, creating room in the curriculum. I kicked off a conversation with Patrick and the remote demolition tool that they're piloting. We would be happy to do something with it. He knows our superintendents and was working with blocking our trailer at one point. Had a little bit of a, conversation with our safety manager over there. He's like, I was like, that's our safety manager. So getting just to know those teams, and our jobs are totally open for that. I think that would really change someone's life to get on an active construction project with one of our professionals and walk a job. Simple to you.
I promised Mitch I wouldn't mention UCLA, but I have been actually speaking at some of their civil engineering classes. So the way that it worked there is I did know the professor there, so they were just like, hey, I got an entry-level civil engineering class. Can you just come in and have one class where he was talking about safety and how to integrate with everything? With that, they gave me the curriculum. So I was able to kind of say, okay, let's shape my conversation around what they're already thought. So
It's just something that might add to that. Great ideas, by the way. We talked about technology a lot today, and I think there's a lot of overlap with construction technology, safety technology, how technology is used in the construction industry. There's a lot of overlap here, so any of those courses I think would be a great area where you could insert safety professionals. Also, I got to say, I really loved your idea about how you run your classroom with different techniques about safety. I might have been in one of your academy classes, so I really like that idea. But really just structuring each classroom in a way that incorporates safety moments or something regarding safety to build those habits so that when they hear the word safety, it's not a foreign word to them, right? It's not alien to them. So, those things, and then maybe if you're talking about equipment in construction, or if you're talking about, different material lead times, any of that stuff, you could incorporate hazard recognition, right? That's something that we're talking about engineers lacking maybe some of those skills when they enter organizations. So just hazard recognition workshops or exercises or presentations, those things I think would be a great addition.
Yeah, we teach 2 different courses internally for ourselves. One's creating a dynamic safety culture, which, obviously talks about safety culture, but then also kind of like what Robert said, looking at hazard recognition. And so having some visual literacy. And we've taken some courses back in Toledo, and it's kind of about infusing art, concepts of art and how to basically look, because as we were, born onto this earth, nobody ever taught us how to look. We learn how to speak, but we don't learn how to see. We were just born that way. So going onto a project and using those concepts, I think are great. And that's just another tool in the tool bag for your students to learn.
One thing we used to do, and I'd like to make it a standard within our company, is for our own staff, when we get into a new phase of construction, we would do a training specific to that phase. Whether we're doing a mass X phase, or whether we're in the steel erection phase, or energizing a building and the lockout and tagout associated with that. So we would try to do it. So I would recommend just tailoring a curriculum that deals with hazards per phase on a construction project. It could be very, very basic standard practices, safety practices associated with that, whether it's crane inspections, things like that. That would be one recommendation I would do. And then to tailor it with a job site visit that is in that specific phase. So that way they can put eyes on it. You can always do it with photos, but you can always set it up to where it's by phase. You can see a project that's at that point in construction, so that way they can actually see it in real life.
I think if introduced into a singular course on a single day would be fun and interesting, but it would have the gee whiz factor. Wasn't that cool? I did that. So I think a suggestion could be if and there's a lot of computers, the quality thread. I look at these as threads in the fabric, right? I'm full of garbage like that. And but this is a significant thread. So you have to look at the program writ large of civil, pick on poor civil engineering. But you look at that writ large, or the construction management writ large among the program. Where is the safety touch points? Much as where would be the quality management touch points? So that it's a drumbeat. It's not a single event, which can either be digested by a couple, but forgotten by most. So that's how I would think of approaching it. And they don't have to be long touch points. I mean, the safety minute, I think, is actually such an immersion. It's, it's like the old Pledge of Allegiance, which nobody does anymore. But back in my day, we did the Pledge of Allegiance every single day. And you didn't even know what you're saying half the time, but eventually you kind of thought it out. And the same thing might happen here. So I don't know. I just commend that to you.
Okay, very good. I think we're out of time. I'd really like to thank this panel. Once you got going, your discussion has been fantastic. So thank you very much.
All right. Welcome back, guys. Hope you guys enjoyed your lunch. So today we're going to have our third and final keynote speaker. So please join me in welcoming Josh Canner to the stage. He's already up here, but here you go. With over 2 decades of experience in enterprise software and a strong focus on the AEC industry, Josh is currently the Senior Director of Product and Strategy for Oracle's Construction Intelligence Cloud. He specializes in leveraging data and analytics to enhance safety, quality, and project performance. Previously, he founded New Metrics, an AI-powered safety risk analytics company acquired by Oracle in 2022, and co-founded Vela Systems, a pioneer in construction technology, also later acquired by Autodesk. As a graduate of Brown University with an MBA from MIT's Sloan School of Management, Josh remains passionate about innovation in the field. So let's give him a warm welcome.
Thanks, guys. Thank you. So I want to start with just a quick apology. I came all the way from Boston to be here, and the first part of the apology is sorry for bringing the really bad weather with me. All I can say is I feel right at home. The other apology I have to make as a Boston guy here in LA is I'm really sorry the Celtics put the beat down on the Lakers the other night. I feel bad about that. I gotta say, it was definitely a new experience watching a Celtics-Lakers game in LA. I was like, wow, this feels kind of strange. So kidding aside, I really appreciate the opportunity to be here. I'm super happy that we could make this work. Burchin and David and I go back. We won't say how many decades, but maybe 2 decades, quite a bit of time in this arc and this world, the community, the friendships and the relationships that is construction. Like so many of us in these panels, we've talked about people and relationships. I'm really happy and proud to be a technology provider for 20 years to our industry, which has not only been a super rewarding career, but also the place where I have some of the best friends and colleagues in my life. So it's really a pleasure to be here, and I'm super happy we can make it work, Burchin. Okay, so I'm going to talk about a topic that is pretty new, and I don't think many people have heard about yet. It's this new technology called AI. That was a joke. I'm trying to keep you guys awake here. It's lunch. You're going to start getting a little tired. The food, like your blood's going to go to your stomach. It's going to go away from your brain. So I'm going to try and keep it a little bit light. I've been in construction tech for 20 years, enterprise tech for 25. The 20-year history of construction tech, as you heard in the intro, now spans 2 different, you can think of them as platform changes, right? So if you put on your technology hat for a second, right? Let's go way back. Let's go back to like the 80s and 90s. There was a platform change where we went from like mainframes to desktops, right? And then there was a platform change where we went from stuff being on desktops and servers to the cloud. And then there was another platform change going from cloud to mobile. And now we're in a platform change going from disparate, unconnected systems to connected data and AI and how that can be used. And in each of these platform changes, at each one, there's a massive opportunity for our industry to be able to not just change the way we use technology, don't just replace a technology, but really reimagine the way we work. I've been fortunate to work on 2 different platform changes now. So originally BIM 360, which is the Autodesk product, was built on a product that a co-founder, Adam Omansky, who is an architect with 10 years of experience as an owner's rep working for the Four Seasons, and we founded back in 2005. The whole concept behind Vela Systems was we now have mobile. How can we reinvent the way we manage field work in construction? You have a mobile device. Now remember, everybody, like this is before the iPhone, right? 2005, 2006. All right, let's get your arms moving so you don't fall asleep. Who here remembers a tablet PC? Yes, tablet PCs? Come on. Yeah. All right. Who here used a tablet PC? Yep, all of those. Nice. Yeah. The tablet PCs were $4,000. They were $4,000 back in 2005. They had 2-hour battery lives. They ran Windows XP, and we put construction software on it. Field superintendents had to take, I'll use this as a prop, there was a stylus you had to use. You couldn't even use your finger. When you were in the field, and what we did is we built quality, safety, equipment management, 2D and ultimately 3D document management, all on tablets. The first thing a field superintendent had to do is they had to take this pointer, which was a pen, that was attached with a really flimsy piece of like cord. And they had to go to the bottom left to make anyone remember the Windows start menu, right? Right? Yes. Thank you, David. They had to click on the bottom left corner just to get the interface to work. And then when the iPad came out, everyone thought, hey, this is just a big iPhone. It's never going to succeed. It's too flimsy for construction. And also that it's going to be hard to get mobility to actually work in construction. But now if you go to a job site, if you think about it, what mobile app, what field process isn't either on an iPhone or an iPad or is Google compatible for Android, right? So the next phase of the journey is tied to the platform revolution around AI and analytics. Our board of directors was always asking me, Josh, why can't we make more money? Like how do we, and for these particular board of directors, it was about the data that was being gathered. And there was, the money part was secondary. They were totally right about the fact that with the shift to mobility and construction, we are now gathering more data than we ever had from what's happening in the field. And it's a massive opportunity to be able to use that if, and I'll echo what Bill and Ed talked about this morning, if that data is a core part of a program that has to do with organizational change, human behavior, and culture. The technology, and this is 20 years in construction tech. Trust me, I've done my fair share of job walks and trainings, and because early days as a startup, I would be selling the software one day, and then 2 days later I'd show up. I had a different card, which had I went from being CEO. The next day I'd show up and train the team, and it said trainer on it. So you have a lot. You don't have people. You have cards. The right technology, when combined with the right processes, can actually help solve big problems in construction. But you can't divorce the two. And I appreciate what the points you guys were making. It very much jives with the reality I've seen now working across 2 decades in this industry, and actually quite a number of the contractors in this room. So what I'm going to talk about is AI and safety. I've spent the last 8 years working on that problem. We were acquired by Oracle about a little over 2 years ago. And they put me in charge of AI for construction and engineering products, as well as gave me a specific product set called the Construction Intelligence Cloud, the purpose of which is to tap into the data that we're gathering in construction across Oracle products, like who here has used P6 for scheduling, right? Oracle Primavera Cloud, Textura for payments, right? We also have Unifier, which quietly is one of the biggest capital program and portfolio management solutions in use around the world. We have Aconex, which is a construction overall process and document control solution. Very popular rest of the world, starting to get a foothold here. Very strong in, you can think of it as engineered construction delivery, where document control and data control are really important. So those products, but also any other product. The whole point of what we're doing, and it's really part of my mission in this industry, is how do we, as an industry, as colleagues, as friends, how do we move this industry forward using the increasingly digital data that we have? So I'm going to talk about AI and safety, and I'm going to try and get it done in 30 minutes. Although, as you can see, I've been told sometimes I can't introduce myself in less than 20 minutes, and we're already at 14. So let's get to the data. Again, I really appreciate Ed and Bill's talks this morning. You've now heard this point 5 times. The curve is stubborn. That's thus the topic of this talk, bending the curve. What curve are we bending? We're bending the curve around construction incident rates. If you look at it, and this data actually is from a customer of ours in the UK. I think it's interesting to look. It's the same in the US as you saw this morning, but it's an interesting other perspective. It's actually UK data. And if you just put a line here, you can see we've been pretty stuck, as was seen this morning, for over 10 years. The question is, how can leading firms, and ironically, what I have found is that it's the leading firms that are actually working to bend what is already a low curve for their companies, as opposed to the laggards. But how can we collaborate to help drive that curve further? The answer isn't just predictive-based safety. The answer is an overall approach to safety, a program, which results in, to the theme of the day, culture. But predictive safety is pretty important because it's a core part of how you can connect data and field operations as it manifests itself in culture to a better way of running your job. I don't like to actually call it AI or analytics. I call it AI-powered workflow. It's a way of operating that allows you to use the data you have to better deploy your resources where there's greater risk. And in doing so, reduce the risk because you're able to address not just the attention issue, but also the specifics of why that risk is happening. In other words, the AI can help you identify those attributes that are actually contributing to risk. And I'll explain what those are. Predictive-based safety also, you guys, this is a great audience. You guys are super knowledgeable in the area of safety. You're all experts. Predictive safety has been around for years, right? Like there's even companies that have been called that. We're now at a tipping point though. The tipping point for it to actually work well. And the tipping point has 2 I guess a tipping point should only have one dimension, but this tipping point has two dimensions. One is data. So we're finally able to gather data that is outside of safety. I'll say it again because it's super important. Predicting safety outcomes needs data that's outside of safety. The most obvious example is the weather. But guess what? We've run a whole bunch of data science experiments across over 2,500 years of outcomes. Other things like, and this won't sound crazy when I say it, but things like your labor mix on the job, foreman to tradesman labor ratios, the tenure of folks on the job, the kind of work you have going on, your observation rate and how it's changing, and interestingly, tying back also to some of the talks this morning, things like your average incident severity over time. Those are a few of the over 150 different, very specific and actionable features that we've been able to pull out. So that's the first part. The second part is that we're finally able to use some of this new AI technology stuff, and it's giving us more signal. In other words, we used to be limited to just what we knew in safety. Now with AI, we can do things like, as I'll show you in a second, computer vision that can sample the photos. Nothing new. You don't need cameras. It's just what's coming from the jobs and your progress photos. It was like that site safety example from the drone deploy guys. It's a statistical sample that creates more signal around your job site conditions and the phase of work, all of which feed the model. It's not about trying to catch somebody before they step in a hole, sadly. That's a great way of thinking about it. I appreciate the presentation earlier. It's very hard to catch somebody, catch a problem, catch a piece of equipment before it hits someone. It's too late at that point. And it's interesting. If you look at the research, there's a bunch of stuff that's trying now too. They're trying to do real-time sort of alerts and detection. And a lot of that research has found it's more distracting to have the device on the person that's trying to alert them than it is actually just to make them aware of the hazard or avoid the hazard from even happening. So data and AI are making predictive safety a reality now. Let me kind of show you how it works. The core concept, the philosophy behind predictive safety is moving from defense to offense. In our industry, in safety as a practice, there's always the debate about what's a leading indicator, what's a lagging indicator. With a predictive-based approach, you're taking away the debate. Every Monday morning, you are getting a report that tells you which jobs you should focus on. And if you focus on the top 20%, the data tells you that you're actually going to get 80% of all your incidents in the coming over the course of time. So it tells you which jobs are going to have the incidents before they have them. And then it measures itself over time. Because in construction and operations, it better work. And also, we're going to check it 4 times. So we actually provide a way for you to see it actually working. Some of the core parts of what it's looking at are, well, it's actually a theme that we've talked about before. It's not just random data. It's things like your safety observations program. So Devin, you mentioned earlier, it's 5 safety observations a week at Clark. What are the incident severities in those observations? The fact that, I think the guy left, but the fact that people are wearing pants, you can actually, in the data, it's not just our own intuition that those aren't good observations. You can actually see that in the data as you look at the curve of what's actually happening in terms of your outcomes and the quality of your observation program, which, spoiler alert, is a fundamental part of this whole predictive safety paradigm. Observations and having more data about what is, in essence, the culture of safety on your jobs is a huge indicator of whether or not that job is at risk or not. I pause there for dramatic effect because it is really critical. So the ultimate concept behind predictive safety isn't anything new, but it can be powerful if you do it right. It's that you have insights that you're generating, which tell you which projects are the riskiest. You can take action. So the insights aren't just, hey, look here, thanks for playing, sorry, we don't know why. The insights actually tie back to specific actionable features. And then if you take action on them, you can reduce loss. Now I'm going to finish by talking about the specifics around the loss reduction, both from a TRIR standpoint, as well as from a workers' compensation, CSIP, OSIP standpoint, which are really meaningful. The ultimate paradigm here, it's the classic Pareto, right? We want which focus our attention on 20% of things that get us the maximum leverage. It's like a lever arm, right? So if I'm a contractor, as a real example, I have 40 jobs. Tell me which 8 I need to focus on every week. And statistically, because we look at your data, we look at your incident history, tune the model, we say, if you, field team, safety management team, operations team, just focus on whatever 8 jobs we're recommending to you every week. Statistically speaking, that's 80% of your job. That's 80% of your incidents over time. And then that corrects. You can see how the model works over time. You can see, well, it was 80%. Now we had one customer, it went to 84%. We had another one, it drifted down to 76. The model tunes over time, but it's still a big lever on 20/80. Ultimately, as a visual, it's this. You have whatever this is, 50 jobs. Here's the 10 to focus on, or 8. Yeah, so that was it, 48. So instead of waking up on Monday morning and using your trend lines or the safety team's mental models for where to look, this is taking all of that, combining it, and then saying, don't just go to the biggest job, please. Go to the job that's got the greatest risk. And that's been actually a very super interesting aha moment when we're working with ops folks. When this is a real example, a 13 million TI job jumped on the list to 2 when it had been at 14 or 17 the week before. So way out of the money or the hot list before, it jumped to 2 above a $300 million hospital job, which completely, and then it actually had, sadly, an incident. Everybody realized, and some of the reasons there were that they got out ahead over their skis. They had mobilized a huge scope of work, and they didn't have foreman or oversight, the foreman there to actually manage it. The system picked it up, elevated it, because it's looking at payroll data, it's looking at manpower data, and then they were able to actually learn from that and go forward. We pull in a bunch of different data. I want to be conscious of time here, and I won't go too deep technically, but as I mentioned, and the analogy I like to use is, predictive safety. I don't know, another show of hands here will keep you guys awake. Does anyone remember, totally different technologies? Does anyone remember the music players? Do you remember the Microsoft Zune? No? Anyone remember the Zune? Yes. Thank you, Bill. Yeah. It was a failure. What did it do, though? The job was to have thousands of songs on a device that you could play in your pocket. Who remembers the iPod? Same exact thing, right? It's the same concept. Why did one work and the other one didn't? It was about content. It was about distribution. There were a few tipping point factors. That's my point about the tipping points with predictive safety. We're finally there in terms of data and AI. This is the kind of data we pull. We actually pull, by the way, I'm not trying to claim credit for that as Oracle. Actually, as we've been in this industry now for a couple of decades, there's been a very interesting trend around API access. And if you go to Procore or Autodesk or Oracle, you can access their data. If you're a customer, you can access their data and get it out through APIs, right? So as some of the best customers we have actually for the predictive safety stuff we do are Procore customers and Autodesk customers. We act to integrate those data sources because we've done the data science to know what's important. So we don't have to go get everything. We go get observations, incidents, we'll get your photos, project lists, manpower logs, weather data. And we use all of that for this multi-factor. As I mentioned, it's like 150 different variables that we look at. You can think of this, I use the analogy sometimes. This is like your pantry, right? Like think of the predictive models of you're baking a cake or you're cooking a meal. We help you understand what data you have in your pantry from our applications as well as other third-party data sources. And we use that to bake the best cake or build the best model for you at your company that will get you the most predictable and best results. The product specifically, and I won't spend a lot of time on this because this isn't really a product pitch, but the product, we call it an advisor. So it's actually advising you where to focus your time based on, again, it's every Sunday, it runs the model. And what it does is it presents it to your operations teams. It's not, by the way, it's not just for management. There's a whole view for project teams too. You don't want management seeing things the projects don't, right? You want the projects to have their own view and they get it. This is the management view. We worked on this user interface 4 different times. What we eventually got to, because the first people we showed it to were data scientists and they made it way too complicated. We eventually started working with ops teams more because we got past the data science people. We were like, get out of the way. We need to work with the safety team. And where we wound up is that it's the AP college football poll of safety. It's the poll. You basically get poll results, and it tells you where your jobs move from week to week and why, and then what to do about it. So just like a football team might go from being ranked, like if you look here, Voice Towers too, it dropped 11 spots. It's like that TI job I talked about. They move every week, and there are reasons why they move. And those reasons are actionable. It could have to do with your observation rate. It's a really we're at a very interesting point in our industry right now where observation-based safety has really taken hold. And I can tell you at Vela Systems, we built checklist-based safety. I feel partially responsible for taking us with that cohort of safety professionals kind of down a dead end, which is that checklists encourage actually the wrong safety culture. That's what we've learned. Checklists encourage the folks who are doing the checklist to either do it at the end of the day or do it in the trailer or do it in the truck. Observation-based safety is the opposite. If it's done right, it's about engaging. It's about the relationship between the foreman and the superintendent. It's about documenting. The head of safety for Bolt Construction likes to say, every observation is a conversation. Documenting, kind of for the first time actually, what is the character of your safety culture? If you do it right, observations are not a technology. It's not a technology. It's a way of acknowledging the right kind of dynamic culture that you have in the field in a simple, fast, easy to do way that generates real data. The observation systems that we've built that we've now integrated into Unifier and Aconex, they have a score, kind of like the severity and frequency score that we saw before from Clark, that then ties into the predictive models. By the way, if you have your own observation system, wherever it may be, we pull that data into. You don't have to use ours. We recognize that observations are everywhere. We use it for predictive. We use it for benchmarking. And given the taking off my industry hat and putting on the academic hat here, we as Oracle are involved in the CII. So we're actually in the CII Safety Committee. We contribute some of the results of our research to that. Things like this. With my academic hat on, I think this stuff is really fascinating. These you can think of as 4 quadrants of benchmark data that have bubbled up from our analysis of now 25 centuries of outcome data that we've seen be highly correlated and drive predictive outcomes. So the first one is what we call a craft observation rate. So it's a way of looking at your observation program through the lens of how many observations is the right number. Is 5 the right number? Sometimes. Sometimes maybe it's too many. Sometimes maybe you should be doing 10. It has to do with, pretty simply, how much work's going on, but then also what kind of work is going on. And if you have a way to be doing every week, to be understanding those other factors, you can get actually much smarter about your observation program. And in the words of one of the larger water utilities in the UK that has adopted this approach, it makes it real for the safety and ops teams because they're not just doing 3 a week. They're doing the right number for the work that's going on, and then they can see the result in the outcome. So it gets them really engaged. You're not just asking them to go do observations. They can see the result of their data. So that's the first one, craft observation rate. The second one is staff observation rate. Similar thing. So it has to do with your own teams. We do have a bit of a GC kind of CM orientation here, but we do a lot of work with owners as well. So there's engagement metrics, right? Every observation is a conversation. How engaged are the teams? Then there's incident metrics. We have this subject for a longer conversation, but in the CII work and what we've seen happen, I don't want to be, too controversial here, but we actually think there's a certain healthy number of incidents that you need to be tracking. Like we think this push, like what the data show us, again, this is a little controversial, but the data show us that if we're driving to a 0 incident culture, that means we're actually not gathering the right types of incidents. So what we've seen is the healthiest observation and incident gathering cultures see the incident severity drop, which is the next thing. Incident severity drops on that score. It was interesting to see the Clark, you guys have a very similar way of doing this. The incident severity drops. The incidents we capture actually increase. It's a sign of health. It's a sign of health around job site communication transparency, openness, and culture. It's not, I can't remember who said it, but it was on the last panel. It was one of the 20 people up here that was about, the concept is we want to be transparent in what's happening. We want to be talking about it. And incident rates going up, severity going down is a very healthy sign. So I'm happy to share this. We've shared it with CII, where these are numbers and ratios and actual targets. What we've seen is there's tipping points. This tipping point only has one variable, but tipping points for some of these specific factors that we've seen be highly correlated with better or worse safety outcomes. And it's, I say this with all humility, it works. If you've got the right culture, the right team, the right executives driving it, you can actually see really tangible results. Bolt, 60% reduction in their TRIR in the first 12 months, 75% reduction in their workers' comp costs. Why? Their incident severity dropped. So they actually had a 10% reduction in TRIR in like the first 6 months, and then it kept dropping from there. Suffolk, their TRR, it's weird. We see this 60% number come out a lot. It's 57%. And then they did their own study because it's Suffolk and they have a bunch of data scientists, and they did their own study and they're like, we think this is about $1.5 million to $3.5 million a year in avoided incident costs. But I just want to go back to a key theme here. I work at Oracle. It's a technology company. This is not just technology. It's not. If you try and implement any of this stuff without committed executive support and the right culture and the right eye towards the culture that it creates, you're going to wind up with a lot of pants observations, for lack of a better term. But if you do it right, and you can bend the curve. We're seeing it. And that, back to one of the points I made originally, Suffolk, Severn, these companies have actually been traditionally very good. They have very good safety records, and they've made it even better by being able to focus on it. These are all public too, by the way. So if you're interested, you can go, there's webinars. You'll have to hear my voice again because it's me with the customers. But it's webinars with all these folks talking about what we did. The Bolt thing also, in addition to being a webinar, there was a Dodge Smart Market report by Steve Jones and that whole crew. And they interviewed Bolt, and Bolt told them stuff we didn't even know. Like the 75% workers' compensation reduction, they hadn't told us that, but it came out in the Smart Market report. It was really fascinating. In summary, we're at a really interesting point in our industry. You notice I only said the word AI like twice, right? I think AI is just a piece of the overall puzzle. If we have the organizational desire, which everyone in this room has, to change outcomes in the field in the area of safety, and if you're interested, we are doing the same thing at Oracle in the areas of schedule, cost, quality, and collaboration. We are building predictive models for each of those areas to achieve what in our industry, what our colleagues and collaborators at the operations, CIO, CTO, CEO level have been asking for years, which is how can we become less reactive and more proactive in our industry in the key specific drivers of project and program delivery risk. We started with safety. We're building schedule and the other areas, cost, quality, and we have one we call collaboration, which is in every operations person's gut. We're building a model around, is this job going to go off the rails based on how everybody is collaborating? And there's some really interesting stuff you can do. I'll say AI one more time with AI to be able to understand sentiment, to understand trends, to understand how people are actually collaborating. And all of them then tie together. So I'd like to offer, and then if we have time, I'm happy to take questions. I'd like to offer to everyone here to join me, be a collaborator with us at Oracle. As I've been brought in to help run this team, I am opening us up to the industry and offering a no-cost research partner program to Oracle customers, which everyone uses P6, so everyone's Oracle customers, to collaborate with us on this next phase, which is schedule prediction. So if you're interested in being a part of the research partner program for schedule prediction, You work directly with our data scientists. We work with you, your team, your data, and we build you specific models around predicting schedules and try and move this industry forward as we have in safety. Still a long way to go, but as we've proven you can do in safety and move it into schedule. So that's my offer to everyone here, that we can collaborate going forward in this journey as we move to actually use all the data that we're now gathering in construction. So with that, I'll pause for any questions.
Hello. Quick question. So are you going to kill Alice Technologies with your scheduling?
Are we going to kill Alice Technologies? No. Renee is safe. We'll be able to, we're looking to work alongside. They do a lot of, like, kidding aside, Renee and Alice do a lot more around, think of it as outcome, scenario, alternative analysis, those kinds of things. Much like we have the AP college football poll for safety risk, we're going to have the same kind of thing for hard and soft delays, consumption of float, and then the various factors that can drive it.
That is super cool. My real question is actually quite simple. So you just made an offer to everybody in industry. I'm an academic. Does the offer also include us?
If
we don't have huge data sources.
Well, USC, with its set of projects that you have within, your capital program, sure. Okay. Ultimately, it's about data. And in this partnership, what we do is we partner with the customers around their data. We sign an agreement around their data and its privacy. And then we work to build out these models and present back to each participant an analysis of, for schedule, in this case of schedule, their schedule data. We also do it for safety too, by the way. That's less of a research partner program. On the safety side, we actually have a commercial services offering, which is actually very, very inexpensive, where we do the equivalent. We go into your pantry, so to speak, of data. We look at it and we to continue the analogy, we try and bake a cake and build a predictive model off of your data, and we give you the results. And it's often really interesting from a safety program. We say, you know what? If your observation program was more uniformly implemented, then you'd get better, more reliable predictive results. It creates a flywheel because it's no technology. Again, it's not the technology. The technology is just a reflection of your business process. But when you're trying to use the data to actually be predictive, it's a very, very bright light. No, yeah, Severn Trent. Severn Trent is one of the largest. They're our most public owner. They're like the second largest water utility in the UK. We did a webinar with them. Actually, God bless him. He came over from London and spoke at the Oracle conference last year in Vegas. Question, yeah.
I have a quick question. I liked your AP poll, and it trends, right? Because you can see which ones are going in. So, my concern is, this whole issue of fatality, right? Because those are generally high energy and, issues that occur. And so does your model analyze those kinds of things as part of what it's doing, or how does that work?
Yeah, it's interesting. The short answer is it has come out of the data. Because we look at incident, there's two ways. One is we look at incident severity, right? So there's that score, right? And the model's trying to reduce that. And then what it does is it's because we're looking at incident severity, which fatality being the worst, obviously. The model learns to actually prioritize those precursors of SIF, type outcomes. Interestingly, one of the ones that pops out is work at height going on. And we get that data from multiple places. It's not just what activities are going on. That's actually one of the computer vision models that has been most useful in our overall predictions. We just look at job site photos. If we see ladders, if we see people on ladders, if we see scaffolding, like there's a whole bunch of things that just say, hey, work at height's going on, or demo. The head of safety for Shawmut he and I were talking one week. He was like, Josh, I didn't realize. He's like, it's like you showed me one of the jobs. They went into demolition, and a part of the job I didn't even know they were going into demolition. Right. So, the model sees those things and raises them, all related back to this concept of incident severity.
Thank you.
Yeah, Devin, come here. Right. Yeah. So
You don't need to sign up for another program. So change the way you make observations.
correct. Yeah. So on the observation front, we're not here to tell you need to change the technology you're using for your observations program. No, we want to use, I've been doing construction tech for 20 years. I've had it beaten into my head. Like, we got to try and take stuff away. We're not trying to give you more, right? So one of the fundamental organizing principles, one of our core concepts technologically, is we want to use all the APIs and stuff that we now have in our industry to use the data you have. Now, that said, Devin, when we do the analysis of your data, we may come back to you and say, kind of like I did before, like, hey, your observation frequency, is great in the Southeast, or Southwest, but in the Mid-Atlantic, it looks like there are these trends, and it's causing an issue in the data. And the issue in the data is that your predictive results are better in some places than in others because you don't have the breadth, the depth of data. That happens, and that's a really interesting conversation, because it's not just about the data, it's about the business process. And usually what we find is like, oh yeah, that was an acquisition. They have their own thing. We're trying to get them onto our program. There's like a lot that just surfaces itself as you're actually looking hard at what the data can predict. It's not just what is the data, it's how strong is it at actually generating a prediction. And there's a bunch of metrics you get there, right? Like, oh, in this region, we can get 80% of the incidents in the top 20% of the jobs. In this other region, we can only get like 50%. So maybe you want to, and the reason is this, I keep using observation frequency, but it may also be that your discipline around collecting manpower in your dailies isn't good, right? So we actually don't know the mix of labor on the job.
Have you had feedback where you're using it and you find that you're successful, but then where a low prediction or a low incident, they had a catastrophic event?
Yeah, it happens. Yeah, at the end of the day, it's math, right? So, and having 80% of your incidents in the top 20% of jobs, so that means that there's another whole 20% that could happen. And that's kind of why another UI we had played with that we went away from was like, what's your probability of an incident? No, it's all relative, right? And there's always risk, I didn't use, my equivalent of the statistics that Ed and Bill talked about is we kill 5 workers a day every business day in construction. That's the way I describe it. It's, if you just look at it's like the 1,300 or the whatever divided by the number of working days, right? It's 5 a day, and it's 5 times that of suicides, which is, if you think about it, 5 workers die every day, an 8-hour day, right? That's like one die in every 90 minutes. It's really stark, right? So there's always risk, is my point. It's just a question of, particularly has to do, Devin, like, again, with how your team is managed, right? If you have someone in safety on every job, that's great. A lot of companies can't do that, right? It's more of a hub and spoke system. And it's a question of, where do I apply my incremental resources? And this helps you know which job, which may be the job you didn't even think, like that TI job. You really need to go there because they're out over their skis, and you just wouldn't have noticed. Ultimately, like, the test for us on the data science side is, if these reasons come back and an ops or safety person looks at it and it goes, that doesn't make any sense to me, that's dumb, then it's a bad feature. But if they look at it and they're like, oh, that's right, I just didn't have the time to go and find all that information, or it didn't occur to me to actually even look at that, that's where it clicks well.
Sorry,
Yeah, sure.
I work with the state, and our jobs are up and down this from Northern California all the way in Southern California. Based on your what you said about the Mid-Atlantic and Southwest, the AI takes into consideration the geographical differences in the jobs. Does that happen, or your
I would say yes, if it's there. And it sounds like an ambiguous answer, but what we do is we actually look at the data and we see how predictive all the various factors are, you may find that region has nothing to do with your safety risk, right? And if so, we don't really care about it then. The first step isn't for us to tell you this is the way. The first step is for us to look at your data, run it through the model, and we say, your data says this about the way you're working. And that's the model. So that's why I can't, until we run that predictive data assessment on your data, it might be regionally specific, it might be job site type specific. That comes out from the data as you run the analysis. Yeah, question there.
Yeah, just a quick question. You mentioned in one of your previous answers that not all the companies have the resources, and the fact in construction is that the majority of the business are small businesses.
Yep.
We don't have resources to spend on technology. They're usually laggards in terms of adopting technology. I was wondering if you're engaging small construction companies, because most of the companies that you named are big names. Most of the people who are here are from big construction companies. And so I was just wondering because the blanket offer that you just offered to everyone here also was in exchange of some data, for example. And those small companies, even if they use P6, for example, I don't think they have a good repository of the data that they can offer to. So I was wondering, what is your mindset?
So I take your point. You're right on. Like the vision for not the vision, the reality of what we've built in what we call the Construction Intelligence Cloud is a product that allows companies of any size to have the benefit of data science and AI for safety. In other words, you don't have to be so big that you can afford an integration team, a data prep team, and a data science team. Our product has pre-built integrations, pre-built transformations, and models built in so that companies, I think the operational floor is probably like 50 million, which if they're kind of like got some stuff, like you need digital data, right? 50, 100 million, but that's a lot of companies in our industry. But yeah, it's interesting. Like, I mean, I've been through this a few times now. You start with the leading companies, and they're like kind of the vanguard, but then the ultimate goal in construction is like this, right? In terms of firms, right? There's a few really big firms, but this massive middle and massive tail. You build the product with the big folks, and they have some of their own proprietary stuff they do, and then everyone should benefit from it. It's like mobility. It's now really in the hands of everybody. Sorry to take so long, Berkshire.
Thank you, Josh.
Yeah.
No, it's okay. It gave me the microphone thinking we're going to move on, but I'll ask my last question. And it's a question that has asked to me, and I don't like it, but I will ask nevertheless to you. So we have observed each other's career for 20 plus years, that we're not going to say how many.
Yeah.
And you took us to 20 years ago and walked us through to today, right? I know it's a difficult one to predict the future, but if you were to, with all this knowledge and what you've seen, if you can predict the future, maybe 20 years is too much, maybe 10 years, like where do you see us in terms of safety?
Yeah. So, safety is going to be like a lot, and I can answer this because I see it. I also have, it's been very interesting for me being at Oracle. We're a massive technology company, right? I mean, it's billions. We invest in AI, and it's AI core tools that then we as industry groups get to use. So there's a huge movement at Oracle and in actually a bunch of the big hyperscalers to deliver what's called agentic AI. So agentic AI is the ability to combine the reasoning and knowledge of an AI engine with the rules of what we used to call, or still call, robotic process automation. It's like if-then statements. What that means is that in areas like safety, in areas like document control, in areas like submittal reviews, in all of these areas that take a lot of time right now, and invoice review and routing, they are going to be facilitated by smart robotic process automation powered by AI. In the safety area, this means that we're able to process a lot more of feedback coming from systems like this and automate everything from notifications to remediations to action plans so that we can take, again, I said it once already, we can continue taking things away so that you can spend more time in the work and building the culture, building the relationships in the field, so that you're not processing an invoice, or you're processing an OSHA 300 report. It's just happening, and you're saying, yep, that looks good.
Thank you so much.
Thank you. Thanks for the opportunity.
Thank you, Josh, so much for your conversation about AI and technology in our industry. Oh, it's funny, we had a conversation about how us students use technology and AI in our classrooms, and it was a perfect primer to your conversation today. Thank you.
Yes, thank you. Keeping everything we've discussed so far and what we discussed with Josh personally in mind for the next generation of engineers, we have our final outstanding panel moderated by Dr. Bursa Gerber and joined by Dr. Paul Goodrum from Colorado State, Dr. Reza Akavian from San Diego State University, and Dr. David Gerber from USC as well. Please welcome them to the stage.
All right. Thank you so much for being here. And we're appreciating your time and listening in and being the last panel also, or the last presenters. We have a job to keep everybody awake and engaged. So let's start with introductions, because of course I know you all, but people in the room might not know. If you can introduce yourselves and maybe what you're teaching and who you're teaching to. Let's start with that.
Okay. So my name is Paul Goodrum. I am currently the professor and department head of construction management at Colorado State University. Prior to that, though, I've also taught in the civil engineering world in construction, both at CU Boulder and at University of Kentucky. So I've taught both in the engineering and the CM world, and they are different. And I'll definitely say that they have a different approach about how they address safety in their curricula. So, but my background is I worked in heavy civil before I went back for my doctorate, mostly in tunnel projects. So I love the shout out that Clark gave to the tunnel boring machines. And then I've done a lot of research on really workforce development and productivity with CII. So, and there's absolutely a big linkage between productivity and safety. There's just data just so conclusive. Practices that improve productivity will oftentimes improve safety as well.
Hi, everyone. My name is Reza Akhabian. I'm an associate professor at the Department of Civil Construction and Environmental Engineering at San Diego State University. I got all three of my degrees in civil engineering, but I'm focused on construction engineering and management as the teaching topic and also in research. What I teach, in the graduate level, in the undergraduate level, I teach technology, mostly building information modeling, the course that we call VDC, Visual Design and Construction. In the graduate level, also technology-related courses. Right now is my focus. We have a course called Construction Operations Modeling and Technology in the graduate level that I teach. I used to teach in my previous institution. I used to teach construction safety, actually. So I have had some exposure to that as well. Focus. And then in terms of research also, my research currently is focused on robotics, and we do a lot of robotics for safety, actually. And I'm sure we are going to do more on safety, because after this event, we are going to collaborate more with the industry and do more research. So it's going to continue.
My name is David Gerber. I'm faculty here at USC in Burchin's department, as well as in the School of Architecture. Full disclosure, I'm trained as an architect. Don't hate me. I do a lot of teaching at the undergrad and grad level and the civil engineering department. And I do a little bit of research. My research is focused on digital twins at the moment, as well as 3D printing for construction. Again, my background is mostly as a designer.
Great. So we have three panelists with various experience levels and backgrounds. So I'll get us started. So how have you or do you plan to integrate safety culture into your curriculum? And what role do you think technology should play in preparing future professionals to protect health and safety on construction sites?
Look at me. So, in safety culture, I would say in construction management, it does start right off with that first and foremost. We do have a course in safety management
and we see that a lot in a lot of CM programs. It's part of the accreditation requirements to ACCE. In the engineering world, we didn't always have a safety course. Mostly at the graduate level, we would see safety. But I think my experience is that, I have started classes where we all stand up and we do a stretch and flex. I mean, and we had different students come up and lead the stretch and flex. It's a good way just to check in with the students, talk about, hey, okay, we got an exam on Friday, we got a homework due Thursday and so forth. Oh, and then by the way, when students stand up and they get their blood moving, they're better learners. And so it serves a dual role of that. Other aspects of safety culture is that every student that graduates from our program, we have our industry advisory board, give them a hard hat, and we take a lessons learned from the engineering ring ceremonies. It's pretty popular in Canada, is that the engineers get a ring and wear a pinky, and it's supposed to remind them of the risk of failure, and not that a hard hat's a failure, but it's to remind them. And when we give it to them, we verbally say this: your most important job when you go on a job site are your craft professions. And it's not just, and that means that, hey, you can't just be on a job site and says, look at that person, they're not being safe. No, that's your responsibility at this point. So I think part of our culture that we're still trying to get to maybe is having students and faculty stop being bystanders and start being upstanders when it comes to aspects of safety. And so we're still working on that. I think there's still cultures, people see something like, I can't believe that's happening. Well, what did you do about it? So did you do something? Did you say something? So in terms of technology, probably our most, we're just exploring the world of AI. And I think a lot of universities exploring how can we bring this into curriculum. It's not a threat that we can put back in the bottle. It's a tool. It's advanced analytics that look at things versus different regression techniques and so forth. We do a lot of work on 3D imaging, which I would argue 3D imaging, laser scanning is a tool that when you scan a building, it helps you you get perfect design information, which will reduce rework in the long run. And we're seeing definitely a trend with more brownfield construction. And so I always tell people, it's like, you might see a corner that looks like a 90-degree angle, but it's not 90 degrees, like 90.1, 89.8. So we do a lot of that. And that's really to kind of help support better design so that the work can go in the first time. But I think there's a lot of technologies that impact safety almost indirectly, and that's what makes it so complex. So
a lot of overlap with what was mentioned. We do the hard hat thing for the graduation. Our students who graduate in the graduation ceremony, they don't wear cap and gown. They wear hard hat and gown, and they stand out in the crowd. Which is an important reminder of safety first culture. We do have a course focused on safety. It's called construction safety and project management, which is offered to both undergrads and graduate levels, so they can both take it. But we also try to, I'm not teaching that course, but we try to incorporate safety in all of the courses that we teach. In the course that I teach, for example, building information modeling, I put a major emphasis on safety when it comes to site logistics planning, for example. Creating site logistics plan with defenses, for example, and flaggers and gates and everything with safety consideration in mind. I think this is something that I put a lot of weight in their final project when they are working on their final project. That's on the technology side of things. In graduate level, again, I try to take advantage of the latest technology, which is accessible to students. It's a fact. It's unfortunate that not all the construction students, civil engineering students, are not equipped with all the technology resources that they need to develop, for example, a software, an app, like coding skills, for example. But what I do, I ask them to, in my graduate level course, I ask them to create this software, write a piece of code where they use smartphones. The smartphones, all of them almost all have smartphones these days, to wear smartphones as wearable sensors on their arms, for example, and basically train machine learning models for activities. These sensors in smartphones, like accelerometers, for example, they produce different patterns in the data that they generate. You can label those patterns with activities that are safe and unsafe, and then later on, basically test that model to see if the model can tell you if this activity is safe. So this is their term project. We start from the beginning of the semester, and by the end of the semester, they can produce a a piece of code, a software basically that does that. And again, the course is not focused on safety, but I try to incorporate that safety piece into it. And I think that's how we incorporate the culture. Inviting guest speakers, I think that's the one of the most important aspects or pieces that help with instilling the culture of safety, because nothing is going to replace the experience of the field work. But when you bring someone from the field and then they talk to students about the importance of safety first, and the importance of the fact that everyone should go home safe and sound at the end of the day, I think that would resonate in students. That would other piece that we try to help or to implement to help students understand their safety culture.
I'm not sure I can follow you too. I learned a lot today. I have to say that. I don't teach any safety, quite frankly. At the undergraduate level, I'm focused on getting the civil engineers to understand the iterative process in design and engineering and combining that. And one of the gaps would be, do we even consider the constructability in that scheduling and estimating sense? Not really. I'm trying to get them to design and apply themselves in a very arduous way. And do we consider the safety concerns during construction? No. So it's an interesting gap that I have to think about. At the graduate level, I think it's been said numerous times, and it's extremely valuable to the students and to me personally getting to be in the room. It's bringing industry in. But have I asked them all to speak about safety over the last 6-7 years? Not nearly enough is my conclusion from today. Do we actually have a deep focus on the spread of technologies across the entire value chain? You do. So Josh, you're coming back. And I think I need to incorporate some of these methods and technologies that have been shown to me today. So I don't have the best answer for everybody.
It's okay. I don't think the answers have to be the best. I think it's also a platform to brainstorm and reflect on what you heard. Next question, I think you answered a little bit, so I'm gonna prohibit saying guest lectures. So try to answer it in more creative, different ways. And not that it's not creative, but different ways maybe. So, what types of hands-on experiences, including the use of technology, best prepare students to understand and engage with safety culture on job sites? Just to, I mean, sorry I put you on the spot, all of you.
There's nothing to replace getting a student, not just to go onto a job site tour, but an internship on a job site. I've been in both worlds where programs had internship as an option, and you strongly encourage it. And most students will do an internship if it's an option. I mean, it's sort of the market now for how students find employment. But when you require an internship, then you get 100% placement. And so we actively encourage students internships even after their first year. Most of our students will get it. We'll do 3 summers of internship, and that's how a lot of students find employment. And so, and it's just a night-day difference when they come back into our classroom. I'll be honest, internship's good for them, but for us, they're easier to teach after the internship, and they get it at that point. You talk about the taxonomies and the definitions, and they fully understand it. And then also a lot of field-based projects where I tell students in my intro construction courses, I said, we'll give you a hard hat, we'll give you all the safety glasses, so forth, but you need to go buy boots. Nothing like taking a bunch of students out to a job site. You've got the nice safety glasses on, you got the hard hats, and you look around and you see 5 Birkenstocks. It's like, okay, that's comfortable at home, but you got to get work boots. And I say, by the way, have you ever heard of Red Wings? They make really good work boots. And so that's what we can't get you. So we do try to get our students on in small groups on sites with field projects. And that way they get more of an interaction between the craft professionals, the foreman, and superintendents that kind of have that discussions. And then also too, think about what is it when we're talking about topic, how does it relate to safety? So when I teach crane capacity charts can be pretty mundane when you just look at them. But if you start that lecture off by saying, let's do a case study on the big blue accent, with the crane that collapsed in Milwaukee, there's a couple documentaries. And when students see
the man basket fall to the ground with the iron workers that died in that accident. The cell phones come down. They're like, okay, how do we do that? How do we do this crank capacity charge? They listen and so that really, I mean, because we could say safety is so important, but until you see something, we've heard today. I've been on job sites where people are hurt, people are killed. That creates such a huge impression. So even if you don't have a safety course, bring in the aspect of safety to every topic. Talk about here's what happens with concrete exposure. Concrete, you're out wearing your gloves, cement, grout. This is a highly acidic materials and so forth. You could talk about chemical burn and so forth. So I think it's just trying to integrate that throughout your.
I think that's a comprehensive answer. Nothing is going to replace the field experience in terms of the hands-on work. But in my opinion, I mean, there are things, as Paul mentioned, the teaching construction safety. Construction safety could be a dry topic if you only want to talk about construction safety. I mean, you can bring the statistics that are shocking, like dividing it by minutes and days, and say this is how many people who die on a construction job site, and then you capture their attention. But at the same time, if it is not hands-on, if you just talk about these facts, it's gonna get dry after a while. So I think if I don't want to repeat the answer, maybe from the technology perspective, if you want to take advantage of the technology, considering the fact that nothing is going to replace the field exposure, is taking advantage of immersive technology that takes students to the job sites in an immersive environment and virtual environments. We were trying to design this thing called virtual field trips for students during the COVID time that we didn't have the chance to get out. And so that was not a bad experience working with some startups who do a 360 reality capture and virtual reality technology. And so that's another type of hands-on work that we offer to our students, again, not to make the safety class dry, and maybe offer some hands-on experience to that. Yeah, that's.
So
I'll add one thing.
Sure, go.
So completely different and not repetitive, but one of the other things that we're doing, and Professor Tomalin is also doing, I think, is teaching the offsite or the DFMA process, which naturally leads to a discussion of quality, a discussion of safety, though I admit I'm not so explicit or not nearly explicit enough about it. But by combining the design, the engineering, the manufacturing as a partial solution to the overall challenges the industry face, it's also an opportunity for us to discuss the safety component of being inside the factory versus on site and things like that. And then related to that, we're also simulating. So not only do we design and engineer, but then we also create the manufacturing bill of materials, and we're simulating the resources, the JBLs, the cranes, and people that it takes to assemble on site. And sometimes we've even gone down, and I think you've done some of this work, to the ergonomics of the activity itself, which goes back to, I think, one of Iris's charts there. How do we, and some of the other photos that were shown today of bending over too much and things like that. So we are incorporating digital technologies and approaches in order to arrive at ultimately what would be safety results. But I guess I've been more focused on production and quality.
Just to reflect on some of. Oh, I'm sorry. Right. We did use case studies a lot in project management education at Harvard. So I still remember them because they really put you in the context. Yes.
I'm actually currently writing a business case study with the School of Business for Harvard's business school. But it's a focus on AEC through the lens of sustainability, not safety. But yes.
Oh yeah, I mean, they can look at the Ambiance Plaza failure, the Texas City disaster. There are those of us who just know about those that we could talk to them. But if there's right, we won't. But there are none. But if there's a document, and AGC actually does a good job at developing case studies, like construction techniques and methods. So I think there's avenues for exactly something like that to happen.
Oh, it's a great idea. And just to reflect on a couple of things you said, Reza, you mentioned virtual field studies, right? I think that's really interesting, or field visits, because not every school is in a large city like Los Angeles that you have opportunities, for example, to take the students to field trips. But also, even in a large city, you don't always have all kinds of access to all kinds of different types of construction sites. So I think developing these and sharing them among different colleges would be a very interesting idea. Also, following up on what you said, Paul, there's nothing like replicating or talking about a real accident, right? And then phones come down. I have also observed in my research where we work with the virtual reality is that VR is a way to actually get students make mistakes and even have accidents without the cost of really losing a job or ruining a piece of very expensive equipment, right? And that really is, if it's done well, it internalizes maybe an accident. Maybe they caused the accident. Maybe they didn't see somebody approaching and stop the equipment, right? Cost is very low, nothing. But I think it's a good way to also explain something like safety incidents or accidents in a more visual, engaging way.
Interesting you should say that. We are running a case study. We've finished that, which is funded by Caltrans. Caltrans wanted to know if drones flying over the roads would distract drivers. And then we run it in a driving simulator, obviously. We submitted the results to a journal, and one of the reviewers got back to us, why did you use a simulator? Why not the real world? This is not good. I was like, should we do it in real world and distract drivers and then record the injuries and then you're happy? And then they said, yeah, you're right. So yes, simulation, virtual reality could be one way of doing that, or driving simulation, or maybe tower crane simulation, heavy equipment simulation. These are all great ways to make mistake, because then you can distract them and see what's the effect, or instill that culture of not being distracted. I mean, it's important not to be distracted. So just
Isn't this how we train pilots? Just saying.
Great examples, right? The more immersive training could be in pilot training could be great. So my next question is, I know all of you are involved in research and it's really important, I think, in this room. Teaching, of course, safety culture is the topic, but I really cannot separate research from teaching. There's a lot of intersection, right? So what are some of the things you're researching? And I know at this Reza, robotics and human robot interaction, right? And we as researchers tend to at least think that we're looking into the future, right? So what are some of those things that you're researching or working with that you can see? And I don't want to talk about technology as the savior, right? It could be actually hindering. And I mentioned somewhere it today, because there's overtrust and undertrust, and there's when you insert technology into your processes, things change, right? You're taking something away maybe from the human being, and what are the consequences? So can you give some concrete examples of, I know this was a long question, but the way that you can internalize?
Yeah. So research on robotics and safety. We do try to. We know that robots are going to be in the construction job site sooner rather than later. They are in some construction job sites in a limited capacity, and the reason is that we want to ramp up our safety practices. We want to take over jobs that are hazardous, the jobs that expose construction workers to hazards. However, the important point is that introduction of the robots into construction job sites should not introduce new hazards. And that's the focus of our research right now. And as simple as, for example, one of the recent studies that we did was for ergonomics, related to ergonomics and worker-robot interaction, because robots by themselves are dumb. They don't know, for example, when they want to hand over a piece of equipment, a brick maybe, to a construction worker, where is the best coordinate in this space to give that piece of equipment, that piece of brick to the worker. If it is too high or too low, considering the height of the construction worker, it may not be ergonomic in a long run, in a repetitive basis, right? And so we were trying to make the robot intelligent with AI, with artificial intelligence, to understand what is the best ergonomic point for that. And this is a very simple, very niche area, as you can tell, but it is important because if robots are going to introduce the construction job sites to save lives, they should not threaten lives, or they should not introduce new hazards or new safety issues. So that's one example that I remember. When it comes to the culture, you mentioned that it sometimes hinders. It is interesting because I was working with this civil engineering water wastewater company. They do construction too. Their CEO actually hired me for digital transformation, road mapping, and strategy and everything. And it was around the COVID time, and he said that we have a problem with the culture, translating or communicating a culture, because everyone is on Zoom. And they're asking me, he said that they're asking me to sell a bunch of buildings and then make everything hybrid or online. But how we can convey our culture, the culture of the company to the people, the newcomers. And I think that's one of the examples where technology is actually hindering transferring the culture, in this case, safety culture, to the new people. And it's a real problem because now many good talents, they are looking for remote jobs. They are applying only for jobs that give them the flexibility of staying at home in their pajamas and work. And that is a problem for transferring the culture of the company, in this case, safety culture of the company. And that's a very good question. I'm not going to give you the answer, so you can hire me and then I will give you the answer. But that's an example of where technology hinders, and then there are ways to alleviate that, but just
All right, we just finished up a series of experiments last year where we're looking at the use of augmented reality, specifically HoloLens, to help improve craft efficiency and reduce error. So we developed this test bed that involved large-scale piping, some 6-inch diameter pipes, and some kind of a system. It was all fake. We didn't have individuals actually wiring live energy sources. But we also introduced a hazard light into the experiment. So we had a cover story that says if the hazard light goes off, that's to mimic a gas leak, and you need to turn off. We had a device. We had a switch that you turn off the device. We involved 100 craft professionals at a fab shop, a couple hundred students across a couple campuses, and we had a control and experiment group. The control group was doing the work using 2D sets of plans. That was our conventional stuff. And then the experimental group was using the AR device. And sure enough, what we found out is that the individuals that were using the AR devices, they were more productive. They produced fewer errors, which is awesome. But there's also this unintentional blindness, is it took them longer to recognize the hazard light going. Some never did recognize the hazard light going off. And there's actually a great psychological experiment called the hidden gorilla. I encourage you to Google it, where individuals are supposed to watch these individuals pass basketball in between them, and another student walks out in a gorilla suit. And 20% of the participants never notice the person in the gorilla suit. And because they're focusing on the students passing the basketballs, so forth. But we observed that with the use of AR, this visualization. So as we're thinking about these technologies going out to the job site, they can introduce another hazard. Now, and we did this experiment with what you mentioned, Matt Hallowell, SU Boulder, and so forth. And so, can you mitigate that? Yeah, probably through an audio alarm, some auditory alarm. We didn't do that. And so, but that is a cautionary note about some of these technologies. Is that you get them on the job sites, they can be a distraction. Not even to mention that some projects that are really in the petrochemical area is this concern about intrinsic devices, which still exists on some sites. So,
The other thing, and a lot of my research has focused on the craft workforce shortage, which we're now in really about the 5th decade with the craft workforce shortage in the U.S. And we have collected data that projects that do report greater craft shortages statistically report more accidents on those job sites. And so probably what you're seeing, there's a lot of factors that are going on why that's flat, why we're not breaking that ceiling. And probably because there's so many different factors going into that. And I say that, and I wonder how many, as a raise of hands, how many of those who work on sites have enough craft professionals on your job sites. And so that shortage is impacting all the sites right now. And so the question is, how can we get more craft professionals in the industry? Or do we need to start thinking about broadly, how can we build projects with fewer crafts? And so we talked a lot about, the digital technologies on job sites, visualizations, but I think we also have to think about the material side of technology, prefabrication, modularization, quick coupling systems, and so forth, that we can actually be as productive and reduce the exposure to hazards on the material side of things. So those are the two things that I can think of many about these.
Just real quick follow-up. That's something that we're trying to teach, really. I wouldn't call it research per se, which is the modular approach. In terms of my research, again, I would say it's not really been safety focused. It's about developing digital twins. I know it's a big buzzword for a lot of people. I have 2 projects. One is with Space Force in New Boston, and the other is the digital twin we built here for our new Ginsburg Hall, which Jose Alde was the project executive for Turner, and Chris was obviously a client. And really what that's about is finally realizing that the people are the most important thing at a university, but then the real estate is probably our second most valuable thing, but we never treat the real estate or the assets in the real estate portfolio as instruments of science. And so I've helped turn one of our buildings into an instrument of science, which again, eventually with the 3,000 plus data points that we're being able to provide people real time, can lead to safety training and things like that. Though our purpose was to provide this instrument of science, a platform for all kinds of researchers to explore the building's data, from whatever Burchin does to a cardiac surgeon for all I care. It's meant to be open, and one can start to think about all those things that we can learn from it. So that's my research.
Thank you. So if I take a poll here, I would say probably 90% of you are engineers. There are a few architects, but I would make the argument that safety culture is an interdisciplinary topic. So who are we missing in the room?
Organizational psychologists, I think, anthropologists.
I'd be social scientists, bro.
I mean, I believe in convergent research, the fact that bringing in individuals from this computer science, engineering, but also behavioral, but also the economics, the business side. I mean, when you get those 3 disciplines together, then you see all sides. Like this, we can introduce a technology. What is it financially feasible for the long term? What's the next step? So,
I like what. Go ahead. I was about to say that, Iris. I like what I forgot. It was you. Say your first name again. What Rob was talking about. That remember, a lot of the people we're serving aren't the students that get educated at USC, but a lot of the people are learning how to read at night. I think the workers, remembering who are most impacted by an incident.
Yeah. So that's an interesting, maybe Ed, that's my pitch to you. Maybe one of the next symposiums could be integrating other disciplines. So it's not just engineers talking to engineers. I think this is really important. Okay. So looking ahead, see, we don't have a lot of time. This is my last question, so I can open it to the audience here. What changes do you foresee in the way safety culture will be taught in academia over the next 5 to 10 years?
I'm going to be using Josh's system.
So, data-centric approach, to be fair. I think the field of construction engineering as an academic discipline is about where we were with environmental engineering about 20 years ago.
When I first graduated from university, if you're in a civil engineering program, it was all civil engineering. There was no environmental engineering degree. You just took those courses, concentrations. Then now we're seeing a lot more because the science and knowledge behind environmental engineering has matured. Now that requires a separate degree. Today, a lot of the construction engineers come out of a civil engineering concentration. But I think the knowledge behind construction engineering has got to the point where we can start pushing that down into the undergraduate and into the undergraduate programs and start giving out separate degrees in construction engineering. You can get your professional engineer's license in construction engineering. APEC focuses on construction engineering. And that gives the civil engineering world, the engineering world, a lot more capacity to teach courses in the construction market. So
here's the challenge and loose pushback. How do we get young people interested in civil engineering and construction engineering? That's I think maybe not answering your question, but I think that's a big challenge that I see.
Yeah, I mean, I think again, it's an exciting field. We're talking about the technologies today. People think of construction as a lot of hard hats and pickup trucks. And I tell people, yeah, go to the job site. There are a lot of hard hats and pickup trucks, but there's a lot of advanced technology that's coming down the pipeline that involves more hands-on activities than your typical construction student or typical engineering student would want to have. And when you teach a construction engineering curriculum, you can actually teach safety engineering in the curriculum. So I think it's about how can we start designing projects so that they are more productive, they are safer. And we've been talking about design for safety now for 3 decades. That knowledge it exists a lot in the graduate program, but I think it's time we can push it down to the undergraduate program. We're just maturing. So I think you will see a lot more construction engineering programs to get a lot of topics we're talking about today into the engineering curriculums.
I think next 5-10 years, the elephant in the room is AI. It is going to affect everything, including safety and safety culture. That's for sure. And then things are going to change in terms of processes, like modular construction, for example. And then introducing robots or cobalt collaborative robots into the construction job sites. And then we need some new safety protocols, safety policies, and safety culture around that. So that's going to be something that we probably will see. But at the same time, I think the safety culture also should shift, and how we teach it should shift around the notion that AI is not as intelligent as it seems. ChatGPT knows what the right answer should look like. It doesn't necessarily know the right answer. It will give you a very well-crafted answer, and when you're reading it, if you're not an expert, you'll say, yes, that's it. This is definitely the correct answer. But if you are an expert, you tell it's holistic. So I think getting awareness around the capabilities of AI and its shortcomings would be very, very important for the leaders in construction companies and safety leaders in construction companies, because AI is gonna be there in different levels, but we need to make sure that it's not a last level. It's not a decision maker. It's gonna be an inter to that level, helping, not necessarily shaping, and then contributing to the final decisions.
And I like that. I do worry about the behavioral side around some of the AI decision systems. Is that there's I think we're starting to see some studies come out that talks about there's human blind spot sometimes trusting AI. And AI doesn't make mistakes. It's just following the algorithm, but but sometimes it does need to be checked. And so I think there are some studies that say they'll trust the AI system more than if you was making a decision. And I think we got to be careful with that. It's a first step to guide, but you have to know the process well enough to say, is this the right answer? It's like a coach, right? Sometimes you take advice from your coach a lot of time, but sometimes you say, no, coach, I kind of know what I'm doing on this. So I think you got to still have that.
Depends on how scary your coach is.
You made me think something. I've been around technology development for the last 2 decades. I've seen technology being developed sometimes for the sake of technology being developed and causing other issues. So maybe it's really important to instill safety into technology development as well. So not technology for supporting tech safety culture, but safety supporting technology development. Anyway, I'll leave it with that, and I'll open it to the audience, specifically also the students. Please feel free to ask your questions. You're part of this event.
You might take it that way. Um, yeah, I'm smiling. I'm not sure how I can truly answer it. I can answer it through two lenses. One is as an educator, and then one is as a reformed architect or project manager, let's say. As an educator, what I'm trying to do is instill and it goes back to the former question, which is instill the importance of data, technologies with an S, integrations, which is the notion that we can break down the silos or at least speak a lingua franca across the silos, and sustainability. And so that's always been sort of these four pillars of knowledge that I'm sort of pushing. I think when it comes to design errors, whether it's underground utilities or for me, it's in buildings, it's clearly, again, on the professional, let's say, side of my life, it's clearly been always an issue of not the technology, communication. It's humans, right? We can have the best tools. It's in 20 years ago, the issues I faced were really the exchange of data, the differences, and there weren't APIs or all kinds of stuff. And we didn't use light tables anymore, though I did that as well. It's always been the communication. And then the communication is driven by culture. And that culture, it still exists for all of us, is still a work in progress when you think about architects, engineers, contractors, and owners, and our legal structures. I mean, if we could figure out a way where risk is shared, where communication is incentivized, then you're going to see less design errors. But I think my colleague who is no longer here, Tyler, is Tyler still here? Tyler made a comment to me during the earlier part of the day that money actually drives safety culture in his work. And he's in a design bid build, low bid environment, right? And I think that's the same when it comes to design and engineering. In the civil engineering world, I thought there, I would commonly get a question from the students like, hey, I got two offers, one from a design firm, one from a construction company. And they're just on the board. I couldn't figure out which way to go. I would always say, start off with construction. And then if you want to, you can jump into design later on in your career, because that will just make you a much better designer. I totally agree with you. Totally agree with you. Design education, we're not taught how to build. We just aren't. And that's changed through VDC education and through BIM, but even BIM shortcuts constructability. So I totally agree with you. And that is something we're trying to change, but it's a lot for undergrad or even masters to be able to do it all.
Thanks. But when you broach the topic of safety and education, safety and research, it has this inherently applied feel to it, right? It's we're talking about real world outcomes. I'm wondering, is there a tension there on the academic side between applied things and things that are, I guess, more traditionally academic research that's pushing the envelope and is often trying to be at the vanguard versus what we need to do today?
Let me answer that real quick. There shouldn't be that tension in our field in construction, because construction is an applied field. It is unfortunate that we don't have a lot of resources from the industry to fund applied research, and then you have to go after National Science Foundation grants that are basic research grants, and then try to convince them that is not applied, although we know that it has to be applied. So there is this tension. You're right, and we hope that through the construction foundations, HEC, for example, maybe in the subcontracting part, NICA, or other organizations, we hope to see more resources and support for applied research, because we want to do something that the result is tangible. The outcome is something that you can take it to your company and then think about it and say, yeah, this should work, and then try it in a pilot, and then if it works, then implement it across the board. So you're right about that tension. I mean, there is that issue, but it shouldn't be like that, at least in our field.
I'll just say one quick thing, and I know we have a question there. Reza said it so well, right? We need funding, right, for doing our research, and funding is more on the basic side and the applied side. But also applied research is difficult, right? You have to go to a construction site, find construction workers or with construction companies. I mean, you guys have all kinds of obligations and deadlines to meet. So for us researchers, it takes effort as well. And we're willing to do that. But I think there needs to be more tightly knit collaboration. On that note, I'm gonna shamelessly advertise Sunny's work. So you have, if you can help us recruit the demolition workers, she's really looking into talking to them. And we're having really hard time. It's interesting. She put together a survey, and 95% of the responses were bots, because we're paying $100 an hour or whatever. So they want to be part of the study. And so we cannot even reach through this old way of like sending surveys or LinkedIn ads to real construction workers. So one of the tangible difficulties, right? We want to work with the industry, but it's really hard to find real people. Yeah. Yes.
But can I add to Josh? I'm really happy you asked this question. I don't live it probably at the same level as my colleagues right left of me, but the truth is we are a $13 trillion annual industry. We're the largest industry in the world. The truth is we also contribute the most greenhouse gases combined, 48%, whatever, for the globe. We employ more people, right? And yet, whether it's the federal agencies or the companies or the big tech companies, we're not putting enough money on the table for people like these guys to do the research that you want us to do. So my encouragement to you guys is to really think about where we can actually have impact and how we need to ask you for the support.
Oh, sorry. And as the Bush
Sorry.
said real quick, support is not just financial, although it is very important. Time and access to jobs. I wanted to thank Clark. I mean, Clark is a big partner at San Diego State University. I worked with a lot of different folks at Clark Construction there. The doors of the job sites is always open. We took robots to the construction job sites to collect data. So just wanted to say thank you.
Gentleman waiting very
Quick question now. This is really good that we're going to incorporate safety culture into students and into universities. And, you know, I hear safety is number one priority for everybody, not only the universities, the industry. And then for the next 5 years, we're going to do this and that. But I never heard anything about having a special class, safety class, construction safety or general safety, being included in the curriculum. I think for the next 5 years, we should have one class. I've had speech 101, economics, everything, but I've never had a safety class. So why don't we talk about a safety class as part of the curriculum?
Yeah, so I think what you'll see in the again, I'll differentiate the construction management program, engineering-based program. Construction management programs, you almost always see as safety first. That is part of the accreditation board requirements. In engineering, we haven't talked about it, but there is a challenge with the 120 credit hour limit that we see on some degree programs. And so it gets down to a point, if we go to a tertiary course where we take out different generations or what have you. And so that's where I think going more towards construction engineering track, where you teach up to 31 credit hours in safety. Then you got the real bandwidth to teach a construction engineering course. So civil engineering is tough. In civil engineering curriculum, but I never was able to see more than 3 to 4 courses in construction. And the undergraduate level.
I think sometimes we blame ABET, but I think when you look at ABET, they're actually very liberal in terms of what they require. So sometimes I think that's on us a little bit as academics. And so I do think as universities, we need to get more agile on this. I think that at my university, it takes 17 steps to change the degree program. And I joke that's more steps than to get a new nuclear reactor online in the U.S. And so I think as universities, we have to be more agile and also breaking out of our silos. Universities, we still keep our silo. We have the School of Engineering, we have the School of Design. Industry doesn't work like that. But as universities, we do work like that very much. It's just based on how we do profit centers itself. So I do think that there needs to be a structural change at the universities. You kind of start breaking these boundaries, but also asking the hard question. If I have 120 credit hours, what is the most important thing for our students beyond industry? And I'll pick on differential equations. Do we need every student to have differential equations? I did take differential equations, did okay, never used it. But we need to start asking those hard questions like, okay, let's rethink our degree programs for what students really need. Yeah, if you're going to become a structural engineer, yeah, you might need that. Or if you're going into these fields, you might need that, better prepared for what industry needs.
If I may just chime in with a few more thoughts, maybe a few more buzzwords that are actually exciting me about our industry is evolving. So we talk about the separation between design and construction, but obviously in the industry there's been wide recognition that we cannot stick to the traditional design build model because we're not comprehensive enough and understand the complex systems that we could use together. So there are these target value design efforts where the designers work very closely with the owner, but also with contractors and suppliers to really design the whole in order to deliver a better product ultimately for the customer and for society at large, sustainability and so forth. Back to the comment that maybe as academics we need to embrace more of this more comprehensive understanding of the systems that we're managing. I think there is some effort that we can, as a construction academics, can put into our educational program and work it much more closely with our designers, the geotechnical designers, structural designers, architects, which sometimes are at the other side of our campus, to do what's called resilience engineering, right? So I think of safety engineering as part of this bigger picture of resilience engineering. It's about people, but it's also about the structure. It's also about sustainability. So maybe there's some opportunity for us to think about what would the curriculum for resilience engineering look like and who are the various stakeholders, the various instructors that we need to get involved to teach our students to really adopt the bigger picture design perspective.
Patrick.
We had one over here.
GI. Yeah. You do it. CSRA.
I know them very well, but yeah, I know their work, but not actively involved. But we do have faculty involved with them, primarily in their design, in some design for safety research efforts on them.
Yes, if anybody's interested in some of the groundbreaking technology of like the critical activities we talked about, or Siddharth, I think it's Bagari, with CSRA, he does these communities of practices meetings, and they're like an hour long, and it's fantastic because it talks about high energy control assessments. And that's where the industry is going. So you think about a class, like that would be a fantastic class to look at the high energy activities. And he actually breaks it down into like the amount of energy it takes, or the joules, or the energy wheel, and all of it comes together in evaluating safety and risk in construction. It's all free. CSRA, communities of practice.
It's excellent. It's excellent. I kudos.
Yeah, it changed the way that we operate, like what we talked about earlier.
That is our entire platform is based on.
And I would say that Jacobs has a similar thing that they do. They're a worldwide design firm, and the laws around the world are different in terms of prevention through design for safety. And so they have a very structured process to go through so that they don't have to worry about meeting their local requirements. It is interesting when you look at the data, and I need to show this morning, that in the UK, the fatality rate is 25% of the U.S. fatality rate. And in Australia, it's about a third of the U.S. fatality rate per capita, on construction workers. And a lot of it is because of culture. And a lot of it is because they focus on design for safety before they get to the field. So there's a lot of issues around that. And I would add on the academic side, I did wear that hat for a long time. And what Paul says, 120 hours, if you're looking at engineering programs, I think the long-term solution is to have ABET require more safety and safety culture stuff. And if that happened, then programs would have to have these classes and have to assess this. We looked at all of the engineering disciplines a few years ago, and at the time, civil engineering didn't even mention safety in its requirements. Aerospace engineering doesn't mention safety in its requirements. I would think safety is important in aerospace engineering. I don't know about you guys. And so, what happens is what gets measured gets changed. And I think that's where we'd like to see undergraduate education go in the future. And so I think that's where we are. We run out of time, I think. Yeah.
Well, thank you so much to our panelists. It's always a very engaging conversation that is difficult to end, but thank you for spending the time with us today.
Thank you. Okay, well, thank you guys for that great panel and for the good questions that followed. That was very engaging and very insightful, especially for us being undergrads, getting talks around our potential curriculums. And so thank you guys, just everyone here for being a part of this discussion today.
That being said, we have another break before we get into our last final event for today. So we'll be back at 3 o'clock for our breakout group discussions. We'll be explaining more once we get back. So we'll see you back here at 3 o'clock.